Okay, good morning, good afternoon, good evening, everyone. Welcome. I had some minor difficulties getting music playing, so I wanted to get that sorted out before I went live. Before we start, I want to say Happy Mother's Day to any mothers out there. I know according to YouTube, about probably 99% of you check the mailbox in the demographics. Wish your mothers a happy Mother's Day. I hope any are having a good one. So how are folks? Say hi to PF Dennis and Arthur and RFK91. Hey Eclipse, hey Bill, hey Rod, hey Tor, Derek, Tuxedo, Eclipse, Rushmere. I'm reading them. I might have read a couple. Hey Morden and Kevin, hey Alex, Demlar, Maddie. How are you? How are you, Samoa and Collie? Hey Queasy Diver. How are folks? We are back on the Blackbox build. Mr. Grinch and Steve and Papa Way. Hey Stuart Fabrico, thanks for gifted memberships. Scotty Dog. Hey Jose. What do we got? Eric and Daniel, Laura. Hey Laura and Sean. TJL and Ironus. ASM and Dave, Philip, Robert. Hey Tech Dad. Uso von Sonnenblum, is that right? How are folks? And Pavel and Torben and Nurglerot, Shammy, thanks for the gifted memberships. Derek, thanks for the gifted memberships. Starting off strong. Polymaker Filament giveaway today. Link is in the pinned post and the description. Be sure you enter. I need to actually bring that up. Let me bring that up on my screen because I set it up on the other computer. Hey Ryan, hey Charlie, Mr. Jalapeno, that's a good spelling. Hey Dave, Kirk, let's see, let's bring this up. We are on Polymaker giveaway number 89. It's nuts. Tohos, thanks for being a member. 2 years. 2 years of memberships. It's been over 2.5 years of streaming regularly. So, okay. Blackbox. This is it. This is mostly where we left off last week. So, I made a change based on kind of evaluating things from last week and talking to Chris, KB3D, is I went through and I made the bed frame assemble with blind joints. So the corner brackets, and it sounds like from talking to Chris that that's the way the kits are going to go, is switching to blind joints from those corner brackets from these guys. I don't think the M4 fasteners on here with the washers is strong enough to hold this frame together well enough. And I was seeing that even having everything tight, you could still wiggle stuff more than I was comfortable with. So, hey Reth, talking with wife about getting another printer, and she's going through all my printers right now, asking why they aren't printing 24/7. Sounds familiar. Hey Christopher. Hey Shane. Hey Zombie, welcome. Hey Poity. So I took another opportunity to play with a Milo. I took the CAD for the extrusions and modeled in the some 5 millimeters. I probably should have gone 5.5 or 6 millimeters, but 5 worked okay. But modeled in some holes and brought that into CAM and Fusion and set it up on the Milo and did it in a relatively short order because I was able to put a stop for the end of the extrusion, and then I didn't have to redo my homing probe, my work coordinates probing for each operation. So I did one side, both, and then since the spacing is different, I flipped it and did another program that did the other ones. It worked out really well. It's all back together. We're at the point where we left off last stream. Everything is lined up. The bed is in there in the proper location and orientation. Everything is good. Hey Beartastic, hey Hybrid Robotics, hey Skyrim. Stuart, thanks for being a member. Al from Form UK. From the UK, welcome. Hey, Shane. What else do we have? Start the stream with a like. Yes, so we're gonna continue our attempts at keeping our 300 likes by giveaway time streak going. Okay, let's bring up, so we basically finished guide 3. So the instructions are split up into guides, and let me bring this up. So we finished kinematic bed guide 3, so we're gonna be on to guide 4. And I wanna actually go to the guide, and why is that right there? Let's go to my local GitHub copy of it. Blackbox, guides, and guide 4 is what we want here. And why? Okay, that works. Scroll to the top. Let's just control home. There we are. So Blackbox guide 4. Hey Bruno. Hey Krasimir. GJ, hello. Hot in the UK today. It's hot here too. I've got the AC going. So, ended up doing the same thing in the Jubilee, changing all the inside corner brackets over to blind joints to not do the old-fashioned way with the drill press, and hand tapping only messed up once. So I found out, so that's another interesting thing about the doing the blind joints on this, is it didn't occur to me, and I'm glad I tried to do this on Friday, because it didn't occur to me that these extrusions are not the typical 2020s I'm used to with the Voron and other projects. These have a 5mm hole going down the center, intended to be tapped to M6 instead of M5. So I didn't have a quality, I had a cheap from a cheap kit, but I didn't have a quality M6 tap on hand. So fortunately I was able to find one for next day guaranteed delivery from Amazon that was a nice spiral chip evacuating, good brand. It cost me $20, M6 tap. So I was able to get that done, and it worked really well. I don't think this is it, no. Hey Delvin, hey 1066. I have those extrusions from Ziltech, yeah. So now I have a nice M6 tap for stuff, and it made very short work of it. I did not want to use the cheap one, because if I had broke a tap off in one of these, it would have been tragic. So the tap I bought in terms of brands, so I've bought taps from McMaster, which is a US vendor here, and Amazon. The one I got from Amazon, the brand is YG Tap. So they're YG. And this is the guy I bought. And it is a bottoming tap. I mean, it's what was available, but it worked a treat. I got that, and I got some of the cinnamon smelling Tap Magic aluminum cutting fluid to try that out, and it worked really well. The ones that I've bought from McMaster are Widia. What is this one? This one is an M8. It happens to be an M8. It is a beast of a tap. This is what I used for Phoenix there. Hey Polo. Hey Eric. So yeah, the Tap Magic stuff smells very much like, it reminds me of some like atomic fireball smell from a kid, from candies when I was a kid. Don't drink it. Does McMaster sell its stuff, or does it just resell from other sellers? Well, McMaster is a supplier of all things fasteners and materials and all kinds of, it's a very diverse store. So obviously it's reselling some brand, but they keep their own stock. Hey Sven, Pathetic Puma and Zarp. You have to build an EDM to get a broken tap out. Tap magic, it's good stuff. Using a vented room with good air circulation. Yeah. The one, I did break a tap, and that's why it was on my mind. I broke a tap when I was building the extrusions for the test station. And it was another spiral tap, but it was a inexpensive brand off of Amazon. And I was probably going a little too hard on it. So someone noted that I've been rearranging in here a little bit. And the big rearrange is I brought my full-on fastener bins over. And I'm in the process of organizing them and resetting the, making room for a few different types of fasteners. Mostly the zinc plated or the nickel plated, the dark nickel plated stuff. So much of these aren't labeled yet, but I'm committing to staying in this garage for these kind of activities. So that means that this stuff needs to come over here. So that'll mean fewer trips over to the other garage. So, and I have big plans for the other garage in terms of making it a better printer room. It's going to be awesome. But hey, Pedro. Just picked up a broken IDEX printer. Fun. Taps are disposable. I always have to remind myself of that. Yes. Yes. But disposable on the hobby level with the frequency that I use them, if I'm careful with them, they should last a very, very long time. I just need to be more careful. I wasn't as careful as I should have been on the one. Making sure you use the correct, making sure to use the correct stuff, the correct fluids, lubrication. So let's get back to this. Get back to the build. Speaking of McMaster Car, I need to order a bed magnet. They have different thickness. What's a normal thickness of a print sheet magnet? 16th inch is typical. It used to be, if you bought from McMaster, you could only get up to like 8-inch wide or something like that. So you have to kind of Tetris your build plate. Why not make a garage upgrade live stream? Because the process for upgrading a garage, I would get very little actual work done in a live stream. It's spread out over a very long time. Okay, XY motion. Is the bed constrained in 3 points, but only dual Z? Correct. And dual Z is tied together, so it's single stepper. Okay, we have stuff. Ooh, we're gonna need to do some epoxy. Fun. Now, I did a lot of prep on this. I pre-tapped all those M3 holes. We did that on stream for the first few parts. So I did that ahead of time, and I put the heat set inserts and everything ahead of time. So let me zoom this in so I can read it and you can too. Hey, Clownhammer. And hi, MR. Make it a bit hard to tram. WD-40 works well for all aluminum cutting operations. Yeah. Yep, but I was ordering stuff and I needed to fill out the cart anyway, so I figured I'd grab the Tap Magic and try it out. For XY axis motion section, the installation tools and alignment jigs may be printed in a less of the yada yada, words. It's probably said that before. You need to print your own extruder drive gear in the future. If you choose to print an extruder drive gear, it must be printed with 0.2 nozzle and specialized bearing filaments such as IGUS Glide. Do not over tighten any hardware going into roll-in nut installed into a 2010 or 2020 to prevent deformation. And Foreign Legacy, WD-40 helped in tapping all the tips of the holes too. The lengths of the hardware are not substitutable, and a shorter length will prevent proper hold strength. I will disagree in some spots on this build. I think some fastener lengths should be looked at. Is the bed also rigid mounted, or does it have silicone spacers and springs? It is, it has the bed has the, and I might as well take this off because it's just going to get in the way, but it has the Mandela Roseworks kinematic coupling setup. I'm going to put the bed off to the side so I don't knock it around on accident. Hey man, forward to seeing it, Murph. Yep, I'm looking forward to it too. I need to book my travel in my hotel. I haven't done that yet. That's actually kind of pressing. Okay, locate the CNC X-Plate Kelvin external cooler V2. It's here in the box. That's a mouthful. There it is. It's got to be this guy. Hey, Maurice. Nicely packaged. Mandela does such a cool job with these cardboard, laser cut cardboard stuff. Squeeze around here and empty my little trash bin. So okay. I need to straighten up in here again. It's an obstacle course walking through. Hey, the GPs. So this is a nice little machine piece that we're going to be working on today. Some spots for, I think, some little pins to set the kinematic coupling. So, okay. Mix your aluminum to steel epoxy according to the manufacturer's instructions. Using a disposable toothpick, place some epoxy into the machine pockets of the X-plate where the 3 by 8 millimeter shafts are to be placed. It is not necessary to use excessive epoxy and too much can interfere. It's best to place a bead of approximately 2 millimeters at each inside corner where the shaft will rest. Use tweezers where the epoxy was applied. Center each liner shaft. Should that be linear? In its pocket using the tweezers. It is best not to rotate after they encounter the epoxy. That makes sense. Only parts of the linear shaft that meet the X-plate should be in contact with the epoxy. Now I'm gonna of course point out little typos and stuff when I see them, just mostly for fun, especially when it's just a spelling thing. It's just for fun. But all of this is being redone. So when we get into the further guides, we'll see the new style, but the guides are being redone. Learning keeps our brain growing. Yes. So, are we ready to do that right now? Only parts of the liner shaft that meet the X-plate should be in contact with the epoxy. So this is kind of showing where those go. To ensure proper positioning while the epoxy dries, place a still bearing ball located in the FDM tool hardware kits onto each set of kinematic points, and then place a heavy object such as a book or a board on top of the bearing balls until the epoxy is fully cured. We are not intending to epoxy the bearing balls. Correct. Okay. So we get to, let me put this out of the way because we're not going to need this for at least a moment. I need to get my workout in today anyway, so. Let's switch over to here. There we go. And we have a couple of electronics, have motion. Let's find all the things we need. Have epoxy that came in the kit. 1, 2, 3 block would be good. We'll hold the bearing ball in place as well. Yeah, that's not a bad idea. As long as I can make sure that I get it placed such that it's on there. might be able to throw like this on there. That's soft jaws for my vise. Something to make sure that I don't put the, yeah, I think that'll work. Or I can use a piece of, here we go. Use a piece of, acrylic with a, yeah, put that on there and then a 1, 2, 3 block on top of it. Keep it nice and good. Okay, so that's going there. We have pins that are where? Not there. Are they in this? Or I don't know that they're in here. Probably in another spot. Any wax paper? That's a good question. That's a good question. I may just use, I've got a couple of soda bottle caps. I might mix it up in there and use that. We'll see. I need to find, so we have an FDM hardware kit, which it said use a couple of the 8mm balls from here. So there are a couple right in there. So let's just grab them out of this one. That stuff back in there. What else do we have in here? We've got all our FDM tool stuff. For mixing, I thought you need something to protect the 1, 2, 3 block from glue smear. Oh no, I'm gonna put this on top of here. That's interesting. There's not 3 points. I don't know if I can maybe grab an extra and then just put that across there. That might be good enough. I don't know how far down they're gonna sit. I bet you those countersunk holes are gonna be good enough. Yeah. Where are the pins for the, might be in here. This is the miscellaneous and others, but there's bits of, what do we have here? Magnets. Those I think are the pins. 3mm by 8mm shaft. Yep. Okay. What's do I have in here? Ooh. Worm gear. Motor set. And that printed output shaft. Tiny little dowels. Yep. I found them. I found them. I do not have, I don't think I have toothpicks out here. I don't really need toothpicks when I got a nice little, I can just wipe that off. I've got, these are basically disposable. I'll use one of those. And some paper towels for mess cleanup. Okay. Yeah, I like this actually. This is kind of neat. That's gonna go over there for now. I'm gonna grab another. Okay. There we go. We'll leave this in here. I'm gonna do 2 of those bearings right there. So let me grab another FDM kit. And grab 2 more that are going to be to put on there. I use a bit of filament. Oh yeah, that's a good idea. Yep. There and there. I only need 3 to define a stable platform, but 4 will be fine. Okay, let's mock this up. Can I get any closer? Nope, about that. That's about where it is. So here are our pins, tweezers. So these are gonna go like that. Those are gonna go in there. And these are gonna go Right in there, right? Okay, those are a little more tight. This is good practice for what method is going to be best to. Yeah, those are really have to go in just right to get them in there, and if I'm not supposed to okay. You're building a printer where your gummy bears? I know. Those little free screwdrivers from China can cut up and use for alignment pins and small metalworking projects. There you go. So these are going to need to be very, I mean, to the point of they don't actually fit. So this, I know this is supposed to be super tight tolerances, but one of those of the three fits. I'll try turning this around. Yeah, I don't like that. I'm gonna try deburring the aluminum in there, because that just simply, that's in there straight and it's not dropping in. These over here actually have some wiggle room. Stealing some info for Tradic software part from Steve. Nice. Hey, Roller. How long until your gamer subs partnership? Okay, so let's pull these out, and so the one fit in there okay with a little bit of work. I don't know what is the. Here, I'm gonna try something. I'm gonna grab these with my pliers here, and I'm gonna go over to the wire wheel on the grinder and just deburr the edge. See if I can. Just where that's ground. Let's see if that goes in there better. Yeah, that's not. Okay, let's see. Over here, just kind of. There's these little feature here. I'm just gonna kind of ease the edge of it with the edge of my scraper here. Let's see if that helps. But I think some feedback here is the machining on this is a little too tight, or the pins need some adjustment. There we go. That one went in that time. It's over here so I don't. That helped. Now it goes in there. It's like tooling. I have tools I know I'll need someday. Hey, Iconic Fab, how are you? I saw your little mini heat set press. I think I want to build one when it comes out. Oh, there it goes. You know what? That is the one that I. So let's just do a little bit on these. And still do the wire wheel on them, and maybe between the two we can get just that little bit time I finally throw something away, I end up buying a new one. Okay, so let me grab these, and I'll just do one at a time. I can't lose these. I only have... Yeah, that's not great. Came over from Grant's stream, still running. A really awesome episode that you don't want to miss. Yeah, Creatrix, Britt, and Karen, Carson, right? I'm not getting the front of this. I'm kind of easing the edge here, trying to... Does that one go? So let's see, is it a different fit for each spot? So is it the pins? Yeah, that end one, so it is the pins. Because that end one was an easy fit for one of these. Which one was it? Is it this one? Right here, still for 0 will come out Wednesday. I'll arrange, send you a kit if that's okay. Sure. I would have built it. What is involved? What parts? Okay, I need to do some more of these. Let me see if this works. A little more aggressive on it over here. Just hitting the edges, leaving the center where it's gonna contact. Yeah, that fit in that time. Let's see. Take this one over there. Hey Luke, welcome. First order reach, one super organized drawer. Yeah, so I have one heat set press, but I use it so much, I want a second one for a different size. So that's... Okay. Yeah, these are not fitting all that great. Get those two. This one, if I remember where those go, that'll probably be okay. Which one are you doing? I'll do the new 0. This step looks tedious. It should be fine normally. I think some adjustment in either that machine part or these pins is warranted. Trying to do this with minimal adjustment. Took me a couple of times to get mine in just right. Yeah. Okay, let's see. Is there? Grab my, where'd that thing go? And let's see. This one went over here actually. This is not really what I was expecting. Just hey, Anton. Would a drill truck and a sandpaper be more efficient? It's so small. And I'm trying not to scar the center of it where the bearing is going to set. Just trying to, okay, so here's the plan. I can get it in there pretty easy now. I'll use my Nipix pliers to make sure they're seated, and then I'll set all the weight on. And we're gonna set these off to the side where I know they can fit. So they're gonna set around there. These both fit in just fine, so no problems there. See, that's the fit that I would expect. Wasn't paying attention. What's the issue here? The tolerances on this part are a little tight. There is, I'm going to clean these, just get a little bit of rubbing alcohol, try to get any bits of grease out of there. Hopefully give the epoxy the maximum amount of maximum chance of sticking. Okay, so that goes there, there, and there. And these two. There and there. everything's hopefully clean enough. Some epoxy. What do I have here? Directions. Epoxy is an equal 2-part hobby adhesive that forms a high-strength bond. So just 2 parts, equal parts, right? Clean, remove cap. Graduated for dispensing equal amounts, mix thoroughly. Place together, sets 5 minutes. Item can be handled in 10 minutes, full bond strength in 1 hour. Equal amounts by weight or volume. Okay, so we're gonna equal dabs of stuff in my lid. And where did this go? That is there. There. Am I set? Am I ready to do this? I don't want the back of my head to be the focus here, so let's change cameras. There we go. These are set right there and right there. Gloves on. I'll be fine. Yeah. Towel. Yes, I should wear gloves. I don't think it's going to be a challenge to not get this on my hands. I take that back. I've got to pull that thing out. Fine, I'll get gloves. I take it back. Pulling that thing out, I didn't realize. Where are they? Here they are. If it was just the tip of this, I'd be okay with the risk, but I'm gonna go for it. Pulling that out is a high chance that I'll get it somewhere. If in any case, the gloves are gonna keep it from me getting this all over the place. Or help. Okay, so that already has a hole in the tip, so I just need to keep this here. And do I have another paper towel? Hey TT, hey Vaughn noob. I'm just getting our hole set up here. So now this comes off, and this is what I figured I wouldn't be able to keep from getting it on me. So we're going to set that there. That's that one. Make sure I keep these separate. Yeah, because these can be a pain to get out. Wow. Safety third. Hey, I got, gee, that one was in there. That one was in there good. It's gonna go over there. There and there. Okay. Even water can kill if you use it improperly. So this is the resin. Wow, that is a slow pour. I'm gonna bank on not needing a lot of this. So I'm making 2 equally equal sized bubbles in the bottom of the lid here. A little bit more of this one. Equal size bubbles. I'll do the difficult one first. Hey Grant, welcome. Thanks for raiding in. Welcome all of Grant's folks. We are mixing up some 5-minute epoxy. And we will be placing this very there we go. Corner there. Finally, I can get a little dab on the top. That's working pretty well. Yeah, that's working really well. Just in the corners. Okay, so I'm gonna leave that one right there for now, and now I'm gonna put these in place. Try to do this such that here. See, gloves were a good idea. I told you gloves would be a good idea. Try not to rotate this. Okay. Try not to rotate this. Clean it off. Okay, let's try again. This being a tight fit makes this way more difficult than it needs to be. Okay, that's in there. There we go. That's the way to do it. Now that one's in place. I can get that right on top. Get that right even. And then come in here with the pliers. There we go. That's the way to do it. There, even, and then basically press it into place. There. Do I know if there's an orange trident frame for sale anywhere? Orange is tough to find. Okay, now we're going to do the same thing over here, except for this one's going to be a lot easier. getting a little stringier. These will actually just fall into place, or anything like the others. There we go. And one more. Okay. Now we're going to place bearing on each. I'm also going to place one here and here. Then I'm going to place that there and a couple of 1, 2, 3 blocks on it. There. That work? Now I'll just set this aside and let it dry and throw it away. And I'm going to throw the little ceiling caps back in the one it came out of. You don't want to mix these up. Okay, there we go. Little towel, wipe off my tool. Oh, that's the one that I didn't use. This is the one I used. Make sure tweezers are cleaned off. Get this, and there we go. Okay, that was a little more involved than I expected it to be. I don't know if I'll just go for all the available weight. Get this back there. What's next? We're not intending to epoxy the bearing balls. No, that would be a bad idea. Put things away. Okay, those dowels, there's a big proper and XYZ so the tool fits flat against the plates. Need to be proper. Yeah, so that's hopefully everything I've done there is proper and correct for the, there we go. Proper and correct per the instructions. Okay, so we're not intending, that is what we did. After the epoxy is fully cured, remove the ball bearings. These are not needed again until assembling the FDM tools. It's likely that the excessive epoxy may be removed after curing. So we can probably scrape anything out of the way. Scrape anything out of the way that might be there, but I don't think I put excessive amounts there. I think I put what it said, a little dollop in each corner. So, X-axis gantry. Locate the 2010 extrusion. It is located. And remove the blue painter's tape if installed. Be careful not to let the MGN12 carriage slide off the end. Install 8 T-nuts in there. Okay. So look at this, and 8. And 3 T-nuts. Hey, Tina. So this is a 2010 extrusion. It looks a little froggish, right? It looks a little bit like a frog face. Oh, that one's missing. That one's missing the bearing. That one's not, but it's not tight. But it doesn't really matter. We could even use that other one. In fact, I might as well. No reason. I mean, if I need them later, it's more likely that they need to be sprung for another application. So I'll just reuse it. Hey, Dynick. Yeah, I had fun going and wishing. Hey, by the way, we saw Zombie here earlier. Let's wish Zombie a happy birthday. Today is his birthday. I saw him here today, and it did not occur to me at the time, so let's wish him a very happy birthday. We already greased this on a previous stream. Up there. Hey, Joshua. Okay, so that's 8 of those. And I'm gonna need my little alignment blocks. And I think I actually printed the correct number of these per the instructions. Actually, no, I said screw it, I only need 2. Or maybe I realized I'd printed 1 in a previous step. So yeah, I have 3. Place, laid out, what are we doing? M3 by 8. The holes used here are accessible. Yeah, whatever. Way too many words. That's going to be the theme of the build here of the series. Too many words. The new instructions, I'm sure, are better for that. Zombie. You're not supposed to go that way. It's supposed to go the other way. How do you like this build process versus any of the Voron designs? It's versus the Voron designs, it's hard for me to say because I'm so familiar with them. I'm coming into this pretty cold. Versus other builds I've done, other community projects, even those, I mean, they vary. The documentation here needs some tweaks, needs some higher contrast pictures, but that's being worked on. So. Okay, so that and then M3 by 8s. That is being worked on. 3 by 8. That's what I want. That is these. 1, 2, 3, 4, 5, 6, 7, 8. It's that. I do need to go eat my cake now. Enjoy your cake. Oh, sorry. How is the volumes today? I updated the firmwares on the mic on the mics. Okay, so that's on. That is, let's see. This one's a tighter fit than these two. Oh, they printed the same way. Okay, so that's fine. Good here? Okay. Let's see. Once aligned, loosely screwed, refer to picture below. If you have loosely attached, repeat this until all. Now that all, locate the print X axis linear rail installation tool. Okay, I don't trust my installation tools for distances because the instructions say to print them in PLA. I printed them all in ABS and I'm getting some shrinkage. So let's open up Fusion and check this distance. Actually, that 56.5 is what we're looking for. So we don't actually have to check the distance. We'll just use that number. I do have the part here, and let's see how it measures out. Uh-oh. I need a bat. Oh, there we go. Yeah, see, 56.05. So we got a little bit of 56.1-ish. So a little bit. So where are we going? We're going from this side, I guess. So 56.5 is what we're actually looking for. I don't know how much that matters, but I'm going to use my calipers here instead of the little. Pathetic Puma, thanks for being a member. Shrinkage was in the pool. These to one side of that. Yeah, I'm going to pull these to one side of that. I was like classic 0.5. And let's see how straight we got this. Let's throw our there. Oops. Okay, so right there, and that's just straight up. I'm gonna just put that on the 40 right there. Oops, wrong. Never mind. You didn't see that. Nobody saw that. There we go. And that'll be right there on the 10. Okay. So we got a little bit off there. So at the 10, we're going over a bit. So I'm going to adjust that. I'm going to adjust that to be a little closer. These printed spacers are always iffy. So let's loosen these a little bit. Just use one side as the reference. Okay, so if this side right here is right. Here, let's change this to a. Okay. Wow, it's all over the place. Okay, that's on 0. So if we go over here, we want to shift this to 0. And I'm just gonna put that right there just a little bit. Now we're within that tiny bit of. Now we'll see where we're at. I don't know what just happened. What are you measuring? I'm measuring the rail is parallel, the linear rail is parallel to this extrusion. Because I don't trust these. I mean, these printed parts, you see this goes on here and see there's some wiggle. So it's a 2010, yes. Okay, so that's right there on the 10. And we're within like 0.05 millimeters across there. So that I'm gonna call good. Just make sure I got all of these. Go. Hey Josh. Yeah, it's 2010. See the end? It's kind of a interesting shape. Come on. Yeah, black. Okay. Tighten all the M3, remember not to over tighten. Now we get to get into some printed parts. So let's set this aside. Onto the printed parts. So this piece, I tapped that. There's a few of these that look similar. So let's arrange these by the parts that are similar. Um, 2010 extrusion, never seen those before. Hey, Mackey's Lab. Pieces, we got a big piece there, and then a bunch of these, that's fine. And then the various tools. I think I'm done with these. So let's set these in the all done pile. These two stay. So this is saying apply some blue painter, remove just the whole, remove the alignment blocks and set this assembly aside. Just lots of words. Okay, so I already tapped this hole and this hole. I tapped that hole and that one, and I tapped this one. Now this one I did, but it uses a tap that comes in the kit. I don't know if it comes in the kit or if it's available on KB3's site to order with the kit, but it's a 0.5 millimeter pitch M5 tap. Normal M5 is 0.8 pitch. So it's a fine tooth, fine pitch. And then I did that one. Okay, so now we're gonna gather 4 linear shafts, M5 by 35. 5 by 35. 5 by 30. Okay, 5 by 35. And 2 smooth idler pulleys. There's those. So we're going to take our... And then we got 4 of these. And that's the 5 by 35. Ooh. Tight fit. Hopefully that can be shifted around. Slide onto the linear shafts. If the pulley seems too difficult to install, first try to install the pulley from the other end of the shaft. Huh? 2 idler pulleys. Okay. Slide a GT2 smooth idler pulley onto one of the linear shafts. If the pulley seems too difficult to install, try to install the pulley from the other end. If the resistance is still too great, put the linears in your drill. It's not necessarily the end. The pulley should slide onto the shaft with some resistance, but not excessive force. Do not hammer, pound, or hit your pulleys. Each idler pulley contains 2 very small bearings. This type of... So many words. Wow. Repeat this. So what are we doing here? What are we going to end up with? Okay. So trying, what it's basically saying is try both sides. See which side fits better. See? Fewer words. Okay. Oh, that one fit well. Hey, Diogo. Yeah, it's just this one that was tight. Let's see if I can. That one's too tight. Here, which one of these was a loose fit? Let's do that. Use that to push this one out. No, not one exploded diagram. The instructions are good, just so many. Oh. There. A little too tight. Let's see if that is... Yeah, so this one is a little too tight. I'm gonna take a little bit of sandpaper on it. Little piece of sandpaper. Oh, come on. This'll do. Not gonna take much. Do I have pin punches? I have some punches. They're old and questionable. It's closer. Let's go on the end here. Make sure it's cools down too, because that can make a difference in the fit, but there we go. That works. And you only have to do the one side. It doesn't have to go all the way through, according to the instructions. Back in 20 minutes. Almost forgot to get my doggy from the groomer. Uh-oh. Uh-oh. Okay, what's next? So those are all on. Install one of the assembled smooth pulleys. So this is where we need to be careful that we have the right piece here. So this is a short side. That I think is this piece right here. So this is going to be a smooth into here. Now what I think I'm going to need is to use my 5mm reamer on these. Where did I put that? Is it over here in this pile of stuff, or did I actually put it away? I think I may have actually put it away. Yep. So I'm just going to hand ream this. And I'm going to assume, I'm just going to, while I'm sitting here, I'm going to do all of these. All the way through. And this is, might as well just do. Just do. Hey, Science Sniper. Shout out to Soterical, who made the awesome CAN bus guide. It made it so much easier, yes. What is that on your reamer? This is just a little printed piece that I did ages ago. It's just a press fit onto here. I pressed it on with my vise. Need a little reaming. Yeah, well, I mean, I think early in the instructions, it did mention that this might be required. The fit on these is important. So to have a bit of plastic back into my mouth, to have a reamer on hand is a good idea. Plus this glass fiber filament makes it a tight fit otherwise. This is not on my GitHub. Okay, so now back to this one with a smooth idler. Now that will fit in there. Nice. Okay. Rear bottom is shown below. That's got to be that. And then install one of the tooth pulleys into the other hole. So this one is going to go right there. That's a nice press fit. So make it flush with the bottom, I'm guessing. Hey, 3D Experiments. Somebody sent it to me. I had to tweak it for my stuff, but it works great. Modbot had issues with his suitcase printer and the glass-filled filament. Oh yeah? That's the exact same filament I'm using here. This is the Siraya Tech glass-filled ABS. It's definitely something you have to consider, as the texture can have an impact. So, okay, and then press the rear bracket top onto the assembly as shown below. So now the top is this one. So this, oh, that's already been. Now, the other thing I had done off between streams is, of course, take my flat file and just kind of scrape across these mating surfaces. His parts were over extruded. Yeah, I don't think mine are over extruded, and they still need some care here. I'm pushing these back through to be about centered there. There's a little printed, there's a little tool, there's a little printed tool to help with that. Okay, yep, locate the 2-print linear shaft installation tools. These are barely considered a tool. And I think I might have done another one of those. I should have printed 2, I only printed 1. And all this is doing, I believe, is making sure that you get this centered in that spot, because it just goes in there. So that is centered in the spot. Push it in from that side. Whichever is, and that one looks about right. I hold that there, it holds flush. I'm gonna use that as an indicator. Okay, that one is there. Did you check out my tool? Maddie, I did. And I apologize. I am a super squirrel brain, scatterbrain person when it comes to reading emails and responding to emails. So don't take offense if I didn't respond, and I haven't responded yet to your email. Looks like an interesting project. I'm not exactly sure what feedback beyond that you're looking for, but I wish you luck with it. There are very few cases where I don't respond to emails intentionally. It's mostly just I get distracted onto the next thing. And I can post mine in Steve's Discord. Man, you got multiples. I bought the 3-pack. I mean, I have 3. I bought the 3-pack. What's the all-in cost of this? For a full 5-tool setup, depending on what options and which tools you go with, you're looking at somewhere between $3,000 and $4,000. Hey, Dom. Okay. Video Knipex factory tool. Knipex. There's a 3-pack. Yeah, I got it on sale. You keep an eye on them. They go on sale. Okay, place one tool in the linear shaft recess and place the other tool into the recess on the bottom. Hand vise to clamp the 2 halves. Setting the shaft in the proper centered position. And then install an M3x5 set screw. 3x6. Where's my M3x5s go? 3x4. Where are the M3x5s? Where'd I put those? Did they get left up here? Oh, nope, M3x5, right there. Yeah, totally all right. All I'm after is thoughts about the idea. I mean, tool changes are cool. I don't see enough detail there to give too much beyond that. Ain't nobody want Kenobi? Okay, so, and then these go into here to lock those shafts in place. And I had pre-tapped these. I think it is important to tap these. You run a risk of they're being close to the edge. And some of them are even closer to the edge of stripping that. So it's these 2. And this doesn't have to be very tight. It's just all it's doing is keeping that shaft in there from walking out. There's one. Hey, Dr. Feelho. Changing the hot end only is the main idea. So, to the corresponding, that's fine. It just needs to be centered. I'm curious how critical that is. Okay, remove the hand vise and linear rail installation tools. Install 3 M4 T-nuts into the rail. Now, is this centered? Does that basically center this, or does it matter which side we're working on here? Because it matters, because I've got the logo on the tool head. So what do we have here? 50, no, it's not centered. So that's like 57.5. This is 56.5, which is what we had measured before, right? For that part. So it's not exactly centered. Why don't they just cap the bottom where the pin is? I don't know. I haven't looked at the rest of the assembly. I'm gonna assume that this is still this orientation, so we're gonna go with that. So we are going to go for a 3 M4 T-nuts. No wire hangers. So I got an idea the other day for the other shop for filament storage. I have a little cubby, little nook for the water heater, and I am going to put basically a rep rack style wall of filament right in front of it. It's still going to allow ventilation for the water heater, and I'm going to start above the controls, but I think I'm going to be able to fit like 80 rolls of filament over there. So, okay, slide the assembled y-axis bracket rear. So that's y-axis bracket rear. So that's right on here like this. Line the holes in the roll-in T-nuts with the printed assembly. That's right there, there, and oops. So that's a problem. That's a little bit of a problem. With these T-nuts butted right up against each other, this spacing isn't perfect. Or it is, yeah, it's not quite perfect. This one is... We'll see how it tightens up. I think it'll tighten up fine, but the spacing on these could probably be adjusted. How the black box is going to work. I have to be patient and watch the build. So I thought when there isn't room for 1 millimeter wiggle room. Hey, John. Install 2 M4 by 10 socket heads into there. M4 by 10 socket heads. I think that's these guys right here. Let's see how close I am. Four by 10. I have the wrench on these. Alexander. So that goes there. Yeah, this is not... I can make it tighten. Oops, I didn't check. But the spacing here could be adjusted. And I think I don't know if that should be butted up against the rail, or if it should be flush with the end of the extrusion. Right now I'm going to go flush with the end of the extrusion. And then an M4 by 30 button head. M4 by 30 button head. M4 by 30 button head. Let's see any button heads. M4 by 30 button head. There. I am very much looking forward to this going burr. The pins are trapped with the set screws so the pin doesn't spin. Well, if your bearings are working, the pin shouldn't spin anyway. Okay, so that's that setup. And that sticks out the end a little bit there. Is that in the correct, did I put that in the correct orientation? So if we go back to this page, and if I'm looking at this, I'm actually gonna flip that end T-nut because there's nothing here it's going to interfere with, and flipping it will ensure that it doesn't stick out the end of the extrusion. I don't know if it matters, but it'll look better at least. And I don't think it's gonna hurt to, it's not gonna hurt to flip it around. There we go. So now that's not sticking out the end. Okay. So install those, install that, install onto the other piece. So that is this guy here. So we're gonna go smooth side onto here. It gets pushed in just, so that has a chamfer at the bottom, and that's what I've been using as kind of the visual indicator of how far I want to put this in. Also push that down onto there. There we go. And then this one is going to go over here. We'll do the same thing. We'll use this little printed guide to make sure that that is in the right spot. And then this part is going to go onto here. I guess I'll redo that here in a minute. There we go. That's when it matters. Ajax, welcome. Been looking for some time while I was making the kids lunch. I want lunch. I didn't actually make sure that these turn smooth, and they do. Okay. So those are centered. There we go. And then a couple of grub screws. What's your take about grounding printer frames? I think it is a good idea where applicable. There was a comment on my test station, a little bit of a premature comment in my opinion. And we're just building it, and it's a make it up as we go along type build. So the The comment was, you forgot to ground the frame. I'm like, I'm not done with the build yet. But then I thought about it a little more, and I'm not sure how I'm going to ground that, because the frame doesn't even touch each other. And there's no heated bed. There's no extra AC wires going anywhere. I don't know that I'm going to fully ground every metal part on that build. I'd like to know what the actual recommendation for that is in a scenario like my test station. So if anybody knows for sure and isn't just citing what they think should happen, if you have actual citable reasons for why we should do something different with that, I'd like to hear it. So, how are you finding printing with glass fiber ASA? It's been fine. It's been fine. I've like, there are little areas where the texture of the part, similar to any carbon fiber parts, where that can get a little bit in the way, but overall it's been good. Okay, so this is all this stuff. I kind of skipped through because I knew how it was going to go. And then this is going to assemble onto the other end, I'm sure. Oh, nope. We get to put this guy on. So remove the hand vise and linear rail installation tools. Install an M5 magnet set screw into the location listed below. So where do I get those? An electrician commented to me that I must ground the frame and aluminum plates on my build. For a printer, I do think that when you have a full structure there, you have an AC bed, I think it's a good idea to ground those things. So for my test station, I'm not going to be running any AC anywhere outside of the power supplies. So all of those are grounded. Okay, we need, that's motion. Where was here? Probably in the miscellaneous and other box. My wife and I were discussing your instruction on bearing stack order. I'm wondering what your thoughts are on the washer crown direction in the stack. I usually put the rounded over side towards the bearings. Not just a good idea, it's very essential. Well, yes, in the printer for sure. The interesting part is that 90% of electrical code protects the house. The other part protects the people. Are they in here? Do you know what box those might be in, Boydie? They're probably in with the black stops, wherever those are. Yes, I would agree on a printer build where you have an AC bed and all that, that the grounding the frame and the bed plate is essential. Got Blackbox hardware kits. Where's the black stops? Black stops. I know I saw them. Oops, went over the edge. Black stops. Is that a SSR? Yeah. Black stops. Blackbox hardware kit. Where are those? It's chains. Okay, let's get these FDM hardware kit boxes out of the way, or bags out of the way. No clue. Where are they? Mains anywhere else as an electrician. Interesting part. Grounding also sounds useful in motion systems to ensure any accumulated electrostatic energy is to start, discharge. They're normally in the little tube that the dowels came in. Similar packaging. Okay. I will look at that. I know I've seen them. I know I've seen them. Where did that miscellaneous box go? Miscellaneous and other. Let's go in here again. There's magnets. There's itty bitty dowel pins, 2mm by 6mm long. There's magnets. Those are shims. It's that stuff. Water blocks. Okay, so it's not in here. I've seen those. Hey, Chris. Chris, where are the black stop stuff supposed to be? I'm at that point where I'm wondering if I set them somewhere else. Not. Those bearings. This is all pure motion stuff. Electronics box. Where's the electronics box? Aha! It was off to the side. That would be it. Okay. Thank you. Thank you. There's that. There are some of that. There we go. There's probably some hardware in here for these. That would be, is that these guys? Yeah, I think so. How you doing, Chris? Big thanks to Chris and KB3D for enabling this build. Hey, if this was earlier in the instructions, you could use this to mix your epoxy. Okay, so that little guy, this is the reason for the fine pitch M3. How does this work? Is this a magnet? Yep, it's a magnet. And what is that down in there? Is this just some extra? Are those epoxied in there or something? Hey, Ed. Okay, so this is going to go into the end of this piece. Start threading this in by hand. Make sure I try not to cross thread it in those. Try not to lose it. Here, let's try this. Let's do a, where is it? A little chamfer the end there. Just a little bit. Here, epoxy it in and use a flathead screwdriver for the depth adjustment. Perfect. Just want to thread it in without cross-threading it. So I'll clean up my tapped hole here. There we go. There we go. It'll reverse thread it a little bit and then send it. Now the question is, do I have a wide enough? I'll just use the side of a screwdriver. I have a whole rack of screwdrivers across the wall there, but if you appreciate the momentary noise reduction in chat. Okay, so I don't know how much that needs to go in. it is an adjustment for the end stop. So we'll leave that right there. Looks like a coin would work too. Oh, or the end of my ruler, or yeah. Install another into this location. Okay, so we've got both of them go into this side. So one right there, one right there. Go. Make sure all that is good, and then the other one. These things are fairly small. There we go. Let's see, a quarter is probably too big. Just barely. I can get enough grip on it with a quarter. And I'll just put it in about the same as I did that one. There was a $quarter on the bench the other time. Yep, see? I wonder if this is my thing. Is this? Oh yeah. It's hardened. If I can get that to come out, and I can still, I have these on the bench to use for Loctite, is why I grabbed them. Oh yeah, that'll pop right out of there. Anyway, I'll deal with that later. Have you used those before? Blackstop is super cool. I have not, although Chris sent me one to try on the VZ bot for that Z end stop. I just haven't made that a priority in my project list. Okay, once again, we're gonna go back to these and put those in, and then the same deal, 2 M4x10s and an M4x30, and then this will all go into the printer. So 4x10. I'm going to put these all in this, not in the same direction, opposite for the end one, like that. And this is going to go in here. M4x10. 1, 2. It is Hall effect sensor. Yep. So those will tighten. It's just, I think the spacing could be a little bit better. There, one of those in 4x30. Hey Gert, welcome. Did you have a good time on the birthday stream last night? You appeared to be. I had me some Pueblo Red with my eggs this morning. This doesn't, I mean, this is all going to be adjusted once it gets on the printer, but I'm just making it flush with the ends right now. There we go. that is X. Position the assembled X gantry inside the machine frame with the linear rail facing the left side of the machine. Facing the left side of the machine. Okay, facing the center side. Secure the bracket to the gantry with 3 M3 fender washers and 3 M3x40 socket heads. This is kind of interesting. There must be other bits. M3x40. M3x45. M3x40. So that is going to be 3 on each side. So I'll just get 6 of these out right now. There. And M3 fender washers. So a fender washer has an extra large outer diameter. That's the distinction. Is there an extra large OD? There we are. As opposed to a regular M3 washer. You see. Okay, nice. Yeah, it is Core XY. Okay, I need to clean up enough here to get the frame back up on the bench. So let's move all this stuff the way. So over here for a moment. All those can go in the center. Okay. I'm going to rotate it this way to do this. Probably go to this angle. There. No hex tray. There is a hex tray. It's right here. See? In the corner. Usually do halfway between Americano and Espresso, whatever the Italians call that. I don't know. I just have plain coffee usually. I'm getting the washers and bolts ready. Hey Liz. Ooh, lemon meringue. I like lemon meringue. We are an hour and 4 minutes away from Polymaker filament giveaway time. We're doing good on likes. 300 people here. Okay, this thing is going to go with the carriage towards the right side here. It says the left side of the machine. What? Hold on, hold on. Did I miss? That's the carriage towards the center. Position the assembled X gantry inside the machine frame with the linear rail facing the left side of the machine. That's the right side of the machine. Am I mixed up there? That's the right side of the machine. I've had the whole thing sitting here. This is the front. This is the left side. This is the right side. Am I? Oh, I'm reading this wrong. It's me. I'm reading this wrong. I thought this was the the rail side. It's not, because I don't see a belt here either. Well, the belt's not there. I think this is, okay, so left side. Oh, let's flip this around. Oops, and hit my keyboard. What did I? Yeah, I had that mixed up, I think. I think it goes. Yeah, that picture could use some work, but that's being worked on. So that's this way. And I'm going to loosen all of these just so I have the play. So I don't have to do it while I'm trying to fasten these screws. So if we go here, start with that one. That one, and then we'll come over to the other side and do its counterpart over here. Why don't you put the frame upside down? Because that would be smart. And I'm apparently not feeling smart today, but that wasn't too bad. Okay, now I'm gonna shift the whole rail over to where I've got an even amount of spacing there. Okay, I'm using the stops that I have in these rails as kind of the reference point for making sure these are even side to side. Let's put these in. Did I grab an M3x40 on this one? Oh. This wasn't screwing in. This is a very rare part. I'm going to save it. Anybody see what's wrong here? Something's missing. No threads at all. You don't see that very often. I was wondering why it wasn't threading in. I'm like, huh? It is neat. Okay, I'm going to save that. It's pin mod. Very fine threads. There is 10% extra of every fastener. The Cocoa Press should have come with spare parts, didn't it? Especially it's an LDO kit, right? They always come with spares. Okay, let's just put this up against there and tighten these down. I want to give myself some more work. OpenBuilds also takes 30% off until the end of the stream. PexPeppers.com. Thank you, Garrett. Cool. I am going to keep it. Especially a longer screw. I've seen that in shorter ones. The interesting thing is, These are usually rolled threads, right? For these, they don't tap these or whatever. They roll them. But that diameter, is that how it works? Is the blank have a smaller diameter here? And then when they roll it, it bulges out into the thread? It's got to be, huh? Hey, Jay, thanks for the gifted memberships. I've never seen the blanks for rolled threads. So does it start as a smaller diameter and then it relies on it being squished, deformed to work? Okay. There, remove the blue painter's tape. Secure the bracket. I didn't use painter's tape. With 3, did that. Okay, XY axis motors. So I'm going to put this back down on the floor and I'll just put it right next to me. So that's that part. Heat set already in place. It's like in cartoons where a toothpick starts out as a white a tree trunk. That is a spec die for rolled threads. Makes sense. So I already installed the heat set. And I installed the heat set here. Now be careful on further on in some of these. I almost screwed up and I noticed at the last moment that 2 of them were M2 heat sets, and that's later in the instructions. There, and then locate one of the NEMA 17 motors. Oh, that's the NEMA 8. Oh, that's the that's the pancake one. What's the heat sets can be reused, right? Yes. I reuse heat sets all the time. Here, I recovered this many yesterday. This bin was almost empty. I recovered that many from discarded parts. Okay, so we're taking the screws from the back out of the stepper here. They won't be reused. And then we're going to place this motor bracket and securing with M3x50 socket heads. M3x50 socket heads. It must be these guys. Yep, those are M3x50. So there's 4 of those. Yeah, I don't like to throw them away. And I've got some techniques I've developed that make it not too bad of a process. Okay, I want a, let's see how this works. And then once we pull these out, make sure you don't drop the stepper or whatever and cause it to come apart. Not yet 100% on board with what we're doing here, but we'll follow the directions. Okay, so that's that. Keep that together. And we've got several of these. So it looks like, is there anything unique about these besides orientation? They all, okay, Okay, so one of them is the opposite of the others. And this is the one that matches the picture. Now, orient the motor with the electrical connector facing down. What's down in this picture? The brushes and springs might fall out. What is down in that picture? Is it that way? Is it that way? Is this in the CAD? I needed to, there we are. Let me open up the CAD and see if it shows in there. What's the trick to get the heat inserts out clean? I tried your method, but they all had small bits of filament stuck in the knurling. What method did you use? What method? So I've got a couple of ways I've demonstrated. So I've demonstrated where you take an iron with a heat set tip on there, and you basically put this onto the heat set and you kind of roll it out. I don't like that anymore. What I do is I take a stainless screw, because it makes a difference, and thread it in, and then take a fairly wide tip iron and just kind of heat it up on the side like that. And then you can kind of put some pressure on the screw here, and it'll start to tilt. And at that point, you can just kind of pull it out, and it comes out really clean. Comes out really clean for me. Way cleaner than rolling it out with the tool. And you eventually wear out the tool when you do it that way. You eventually wear this out when you do this. Anyway, I wanted to see if we can tell from CAD where are the stepper motors? Is that you way down in there? Yeah. Let's right click on you. Oops. Right click and find in browser. This is the motor assembly, so let's isolate that. Okay, looking at this, if the CAD is to be believed, that's probably the wire output. And if we're putting this on, that's the other side. I picked the wrong side, but I use snips to cut the heat sets out. Yeah, that's doable as well. Let's grab the other side. This one. Let's isolate that one. This is the one we're working on right now. Okay, so that is down. So if we go back over here, you can kind of see it right here. That's down. So if we take this here, and it goes like that now, this goes right here. Okay. I'd like to look at that design because I'm concerned about that long term. Okay, locate the XY motor installation tool and snap the printed onto the shaft. And then we have a 20-tooth pulley that's going to go on here. in this direction. Your printer is a black and gray box. It's a grayscale. It's a grayscale printer, and I keep hitting the buttons. Is this the one I want? Yeah. Hitting the buttons on my keyboard. So this guy's gonna go here. I need a pulley. Let's see if my, where is it? Loctite, where'd my Loctite go? Did it fall off the end here? I keep knocking things off the end of my workbench. Where is the Loctite? Okay. I don't know where my stick Loctite went. I haven't thrown it away yet. Yeah, I got liquid. It's a grayscale box. And I've got another bottle cap. A little bit in there is all I need for this. What's that? Where is that driver? Huh. My 2mm hex driver. This one will work, but why no Loctite stick anymore? I don't know where it went. It's not used up, or at least last I looked at it, it wasn't dry. I don't know where I put it. It was right here. It is no longer. So I don't know. I don't know. I've got a few things that are missing here. That's okay. Okay, this is going on here in this orientation. Let's see if we have any of the same. Yeah, we won't have any of the same issues on this with the flat spot. I think it'll go to the flat spot just fine. I think. Oh, just barely. I could feel it. It's right on the edge of the where the flat spot ends. Right on the edge. Okay. It's where you last used it, or your son did. Well, I know my son didn't use it. He doesn't come out here. Okay, tighten set screws completely. Remove the printed installation tool and locate a print XY axis motor bracket front. Okay, this is a little itty bitty piece. That's the one. Not a lot to it. Miss Charlie running off with parts stuck to his feet. Yeah, me too. Snap this printed part onto print X motor mount bracket part 2 as shown below. Ah, well, that's interesting. Okay, is that this piece here? Yeah, that's this piece here. Why does this snap into here? It snaps into there. Okay. So that snaps into there. Okay, I think the idea there is simply to give a printable part, a solid edge there. And then this probably goes on here. I'm not sure the purpose, but that's okay. 2 hours in, only 191 likes. Your mom will be disappointed in you. Likes for Mother's Day. Okay, orient the print assembly onto the NEMA 17 motor. Careful to keep the printed parts together. Place the other part and secure it within 3x45. So there's another part that now goes on top of here. Is that this part? Yeah, I think so. I think it's this part here goes on top here now. And then all of this gets held together with M 3x45s. I've seen 3x45s. What size are these things? I bet you it could be made where you could recycle these. If you see no need, I say we remove them. Right now, I don't see a need for those parts at all, Chris. I don't know what they do here. You're bolting this plastic part to the body of the stepper. That piece in there, I struggle to see what it's actually doing. I really don't see what it's doing. How long do you organize a set before each stream? It varies. It depends a lot on how much work I've done on other projects the day before. So we're gonna make sure all of this kind of lines up. Actually interfered for me. Dan isn't around to ask about the thought behind it. Yeah, it's just interesting. It's interesting to see some of the little print solutions. But I really don't see, since this part here is bolted against this solid face of the stepper, that's not doing anything at all. We'll see if I change my mind once we get it into the printer. Will there be any Voron speed builds? Not from me. Not anytime soon. My upcoming Voron content is once we're done with the test station and checking out the, and that moves fine. It's very close to the top there, but it's not rubbing. Once we're done checking out the test station, we'll be working on the 9mm gantry, the double T gantry on the Trident. And after that, we'll be doing the solid fork rebuild, and those will be Tuesday streams. We'll be doing this for a good while yet on Sundays. Hey, Justin. The part bork next to where that heat set is. Well, that's that little part in there, the little extra part that's not really useful. That's a little string of filament from the print process. It's not borked, and it's probably not worth worrying about down in there. Where's my little? Probably not worth worrying about, and I'm going to sit here and worry about it now. There we go. That's a little better. Is that to keep swarf from falling into the groove? Sure, maybe. Thanks, Chris. Thanks for gifted memberships. Are there any plans for an updated Trident release? Well, there's always plans. The question is when. Okay, so that is on and in. So now we're going to put this in the printer. To the extrusion with the tabs at the back for the motor lining up. Does that make sense? Everything makes sense. Okay, for the pictures for what I've done. Secure the top of the assembly to the frame with a socket head cap screw, and then secure the top with another. Oh, down there. Okay. And then we've got some pins to do. I am going to skip these for now. I'm going to build the other stepper, which I'm sure is going to come down in the instructions here. I'm going to build the other stepper. I'm hoping, maybe. Yeah, I'm going to build the other stepper and then bring the printer up here again, and then put them on the thing. These are LDO steppers. What kind of stepper is that brand? They're LDO. You see the KB2D typo in the unboxing stream became a running gag. That was a gag before I latched onto it. I didn't originate that, but I've definitely helped continue it. Someone asked how my Tridex works. I'm working on my Tridex. I'm making progress. So Joey, the Tridex macro and configuration guru, has been helping with stuff, and I've slowly been testing things. I'm hoping to get it to a point where I'm printing on it really soon. Well, I got mine, but that's how Murphy's Law works. Perpetuate, thank you. I was trying for that. Okay, we're gonna do that. I did that already. We got another little, since I did one side and I printed it, I'll put both of those little pieces in. This one snaps in pretty well. Okay. This typo has been approved. What was that? Okay. That. And then the other NEMA 17. So these are this for steppers. They're 1.6 amp, 48 millimeter LDO steppers. It says 48 millimeter. The instructions say 47. Pull these screws out of it. We are 94 likes away and 34 minutes away. Those, set this other piece. So that is, okay, at least on this one, down is a little more obvious, but that's gonna go there. And then the 50 millimeter screws. Chris, are you still here? Were you here when we found the faulty screw? It's kind of funny. Hey, Dirk. I almost said tank. From this distance, it looked like tank, but that's Tarek. Hi, Timo. A big red. Okay, so that should be, according to the directions, that orientation. And we're going to put a pulley on, oh, in the same direction. Okay. Servo motor? What about servo motor? What about servo motor? We got stepper motors here, but there's probably some terms and differences across regions. These would be considered a stepper motor, and servo would be, a requirement for a servo would be active position feedback, right? What is Blackbox? Blackbox is a 3D printer that is designed around being a tool changer. And in the default configuration, it's designed around up to 5 tools. Why are you not wanting to go on? Because I threaded that in too far. Any plans of building a Hevort? I have no plans right now, but if ever the opportunity came up, I would be interested. It's one of those, there's builds that would be like I would seek out and do whatever I needed to build one. I don't have a need for one. It would just be a fun build. Is your build fully enclosed with top hat? This will eventually, but not during this series. It's made Intel third printer board. Do you plan to do a VCore V4 build at some time in the future? I hope to. I have talked to the Rat Rig folks. We will see if something comes of it. But the hope is to build one. It looks interesting. That's the criteria. It looks interesting. You already have the frame? Well, my frame was to my specs. I don't know what it needs for a Hevort. And that, and that. That thing goes on there, and then the other piece goes on top of there, just like the other one. So that means this guy goes on right there, because I think it lines up with this. So that goes on there, and then this larger piece, taller piece goes on here. And then these are really long screws, I'm sure. No, they just go really far into there. 45s again. If you would like, I have a Crow keyboard in red. It takes a RPi Pico. I sent one to Timid. I have a couple left. What is a Crow keyboard? It sounds, is this like in red? Is this like a little play on Voron? What's the deets there? You can always TM or DM me. Can I see motherboard? The motherboard for this printer, when we get to the electronics, we are going to use a Duet. Here, I can tell you what we're using. We're using as the main board, we're using the Duet 6HC. So, duet3d.com, you can look up the 6HC. And then we're using a EB3HC add-on. Okay, all those are lined up. You know what would be actually kind of nice. Probably. Might be a good idea. Is what if I grab an extrusion like this and, oh, well, I need the right kind of extrusion. That's not it. These are useful, useless. It's like a crow shape. Interesting. Goes back there, that goes away. This is one side. Printed parts can go over here. These over here. And we can pull the printer back up here. Okay. Dropped a quick video of what it looks like in Discord. Awesome. Oops, not that one. I wanted this one. What I thought about here is it might be a good idea to push this up in to make sure that those are all lined up. So just kind of using the frame here and make sure all of that lines up when I tighten this down. Yeah, see, that shifted a little bit when I loosened that last screw. Now I can be sure that this is all, these are in a line. It is, no, this is 40-40. This is 40-40. I'm gonna do the same on this one. Push this in here. And then tighten this down. There. Now that'll be forced to be in line. Oh yeah, it is. Hey, Switz. Okay, so now that we've done that and we've got the frame up here, we might as well go back to where we left off on the previous instructions. So let's go up here, right to where we're putting this thing in place. Okay, place 2 M4 T-nuts into the front left extrusion of the frame as shown. That's going to be front left right here. So let's move this out of the way, and we need 40 series M4s. So there we go. One goes there. Hey, Lewis. Something different with the Z kinematics. Is it cross gantry? No. It is regular core XY. Okay, so that one goes there and there. This is the stepper bracket. So if I line these up now, there and there. So then this is going to go in there, right like that. Probably pushed all the way up against the top. Did I get those lined up properly? Yeah. It's right in there. And then those get held in with. Place the assembled front extrusion with the tabs at the back lining up. Top of the motor should be top flush with the top extrusion. And then an M4x35 socket head. That seems to be holding in there okay. M4x35 socket head. 30. That one's 30. Those are the 35s. So this guy up here. And that is a tight to that pulley, but it does clear. It's not rubbing. What bed size? 300. It's 300 by 300. That's tight. And then the bottom screw is going to be another M4 by 35. Okay. Locate that part, and I already tapped that. Locate that. Okay, so I need these parts, and then I need to ream them. So I've got, which part is that? That's this part right here. I'm gonna take my reamer here. I know that's gonna need done. It's really interesting how this printer's build is very different. Yeah, so I mean, kind of the point here is to experience these different designs, right? There were when this was designed. Now remember, this is a design that originated in 2016-17. It has been revised and revamped, but within its original scope. So the things that were important in terms of design and parts availability and stuff is different. It is a tank. And by all accounts, it should be a very, very capable printer. So, hey Falkenstein, what are we testing? See you, Tina. I'm just going through these that are obvious 5mm pins and just reaming them out while I'm here. Reminds me how the Hevo felt like when it came out. Yeah. This is all very close. I mean, I'm able to hand do this. So Ron and Ratgrig got frisky and this popped out. Okay, I guess we got a few here as well. We might as well do. Testing, all my name shows up. Cool. Was your name, were you in here before under a different name? Ooh, that one I am gonna grab a drill for. It's just a lot of plastic to get through. Might as well do the rest of these. Hey, David. Hey, Sergey. Do you think you'd be up for doing a Satsuma 250 build once I've finished up the manual? Might be able to put a kit together for you. What's a Satsuma? Catch me offline. The problem with any new builds is there's a long line of builds, but I could be interested. depending on what it is. All kinds of plastic. I've only got 2 more of these to do. Just playing around with things a bit. I'm assuming the counterweight is used because the bed frame is so heavy the motor needs a little help. Oh yeah. Here, I'll lift it here in a second. One more. All the little plastic shavings. Okay. Yeah, so this thing, hopefully the sound isn't too bad. This doesn't do too bad now. But you add the bed on here. One of Scroll Brain's machine ideas, but scaled for a Prusa Mark III bed instead of the Mini. Ah. Falkenstein, thanks for the gifted memberships. Thunder Keys, welcome. Yeah, it drops quite fast with the bed on there. Okay, back to this part. So we have this one, and we have this one, I think. Yeah, there we are. So that kind of, oops, sure. That's the 2 parts that we're working with right now. Nicely illustrated. Do that again. Could you hear it through there? Can't do a Satsuma because he needs to build a Stinger next. See? The build ideas, there is no end. No end to build ideas. There is end to my available printer space, but I'm about to help with that. I'm going to build another 8-foot workbench for the other garage. I bought an 8-foot workbench to go in here. So Milo is going to have a spot. My little metal lathe is going to have a spot. And Cascade is going to have a spot. But again, like 8 months away from completion anyway. Perfect. Okay, so what do we do here? Oh, we got 15 minutes left and 75 likes to go. What is your opinion in these embedded magnets versus a magnet foil on top of the bed plate? I haven't really used, well, I guess I have a V0 with embedded magnets. A lot of it impacts what Z probe you're going to use, so. I winced when I heard the belts because I'm afraid of frying a board. Hey, yeah, it's not connected. I thought about that too. Okay, gather 2 5x30 and 2 idler pulleys. And pulley seems too difficult. Do not hammer. Yep, words. Words. All the words. 5x30s. 5x45. 5x50s. 5x30s. Hey, Betty Ruxpin. And 2 pulleys. We got 13 minutes and 63 likes to go. We're getting there. Let's see how these go. That one is good enough. That one slides. It's tight, but it slides. Same with that one. Those are good. They're tight, but they slide. Okay. And then we're going to put that into this first one I was working on. In there, and then the top on it. Is that the correct one? Yeah, it's got to be. Now that's interesting. I guess that's correct. This kit organized very well, like LDO quality. Yeah, where the parts, all the packaging and stuff is good. And we're probably going to use a little printed, little printed spacer tool to make sure that this is in about the right spot. Oh, wow. And that makes sense. So that's going to go press it on whatever side. There. Go. And that is going to clear these holes on the end to make sure that's pushed in enough to where it clears both mounting holes, because I imagine that these are going to be used to mount the thing in the printer. Now, I would argue that we don't need 2 grub screws here, for one thing. You only need 1. If it's any kind of friction there, you probably get away with none, because those bolts are going to hold it from being able to creep out of there. Just thought I would say that big gray box I picked up decided to start working fine after I cleaned up, preparing to replace stuff when it comes in. Awesome. Love the username. Marksman Penny Arcade Con. Current print on my V2 has 1,185 layers. Fun. Is this a USA company? Never heard of it. KB3D? Is that what you're thinking? They are a US based place. Yep. It means a lot to me. Thank you. I appreciate that. Was I doing the right one? Are these the same? That's the question. Are there 2 of these that are basically the same? They are the same. Okay. So I'm just building 2 of them. That makes sense. And then we're going to put set screws in here. Where did I put my set screws? 3x6. There they are. Triband going to be a Tuesday stream project eventually? I got to add that to the project list, yes. What is the light goal? 300. We have 46 to go and 10 minutes. We can do it. We can do it. Hey, Latian. 45 to go. And 9 minutes. 41. Hey, hero. There we go. That's 1. Now, I think we can probably just kind of put the other one together. Hey, Obi-Wan. Hello there. Is there a way to help you in any way? Just come hang out. That is the perfect way to help. Just hang out, like, subscribe. That is the best way. I am skipping ahead, but I'm guessing that the install on this is the same as the other. So, a couple of these in. We are 30 away. Remove the printed installation tools and hand vise. Locate this piece. It's another, that's this piece. I may have to steal the idler tension idea. That's what happens when you assume. You will use the tool to set the pre-tension gap of the XY axis belt tensioners. The tool slips between the motor housing and the tensioner part. This is the position where you will hold the tool during the pre-tensioning process. Place the tensioner assembly onto the motor housing and secure it to the housing with two 35mm BHHS. What is BHHS? That's button head, okay. Those are M3x35 button head. M3x35 button head. M3x35. Jarrett, welcome. Okay, so this guy is going to go on here. It goes up in here like this. See? Interesting. There we go. So that's this piece that we were just working on. It goes up in there like that. What are these little cutouts for? So there's this guy is a printed spacer. There's no top. Is this printer Core XY? It is. It is. 26 to go and 6 minutes. So I think that goes right like that. And then we put these guys in here. That says an M3x35. That's an awfully long screw for that. Is that correct? Okay. There we go. This guy up here. Cutouts for the belt, probably. They don't line up with the belt, though. It doesn't line up. Okay, let's loosen this so I can get our little spacer tool in here. I'll just leave that not really tight. Even there. There we go. It has been to UK once and France twice. Cool. So that's that. We have 21 to go and 4 minutes. 21 likes in 4 minutes. We did better than this. We came down to the wire last week. Can we do it again? The washer seems to be a good application in there. Yeah. It doesn't say to put one, so I'm not going to, but. Remove the printed pre-tensioning tool, locate, and okay, so this is getting to the other stepper, so we did these. And then we're going to end up mounting this on the frame on the other side. Grub screw. Can't let those get loose. They end up in candy jars. It's gotta go over there. There. Oops. There we go. Way up there. We've got 12 more to go in 3 minutes. 12 more. 3 minutes. This is going to bolt here, so line up the there. That one's already lined up. Perfect. Hey, sissy kid. 9 more in 2 minutes. These are in 3x35s. Was used for this. Yep. It's on there, pushed all the way to the top, and then tighten through here. Make sure that was lined up. And then I imagine we will do the same. Got 1 minute and 1 to go. We'll get this guy in here. Went to the USA a couple of times, working vacation. Really liked it. New York in 1993. I've never been to New York. Never been. One day. There we go. The Z-axis driven by a single belt. It is, and it's got a drive a shaft across here linking them. And then I imagine the same spacer is going to go in here. So pull this out and realize I tightened those too much already. We are giveaway time. Wow, way too tight. There we go. That goes in there. And tighten this up too. Just touching. The Z-stepper is, yep. It's got a, I don't know how many tooth. Is that a 16 tooth? 16 to 80, so it's a 5-to-1. Is that right? Yeah, see, this is the, I think, what was that, an 80 tooth pulley, and then, oh, it's double geared. So it's a 16 tooth on the stepper to a 40 tooth to an 80 tooth. So it's 10, is that 10-to-1? On the, no, it's not 10-to-1. It's 16 to 40. So whatever that is, 2 or 3. So it's that many to 1. Well worth a visit, but to my mind, that counts for all parts of the US. Okay, we are giveaway time. Polymaker filament giveaway. It is, oh, I hope I did that one right. Is this another one of the same thing? It is. I can't math today. It's 16 to 40, and then 16 to 80. Polymaker filament giveaway. The link is in the description and the pin post. Let me bring up a Wheel of Names page. You have 3 seconds to get your entry in. I will close the entries when we haven't had a new entry in 3 seconds. 16 to 40 carry 1. So let's see. We have exactly 420 responses right now. So, oh, now it's not. So I'm too late to close it right off. So when we haven't had a new entry in 3, 2, 1, 3, 2, 3, 2, 3, 2, 3, 2, 1. Lock out the slackers. It's a game now. 3, 2, 3, 3, 2, 1. 0.5, 0.25, 0.125, 3, 2. Wait, what? Steve partakes? No, I do not. Not even a little bit. But funny numbers are funny because people make them funny, right? 3, 3, 2, 1, 1/64. 3. Okay, we're about done. 3, 2, 1. 3, 2, 1, done. That was a good one. There was consistent new entries. I propose no one enter until the drawing starts from now on. 3, 2, 1. No herbs. No herbs for me. No. Not at all. You saw my wife giving the kids the countdown. Hey, it's Tor. You got the first entry. Who got that last? 437th entry in. Lander Hoostings. Congrats. Okay. Let's paste it in. Oh, I haven't even been showing that. Okay, we are going to do a number between 5 and 12. It's May 12th. 5 and 12. This is like Who's Line. Here to have fun and the numbers don't matter. The points don't matter. Orange. Go 8. 1, 2, 3, 4, 5, 6, 7, 8. Spin. Who do we got? Oh, there's a noise. I can hear it. Not to reward bad behavior. Bigovici. Bigovici? Congrats. You have 2 minutes to say something in chat. Congratulations. If you're in the US or Canada, you get a coupon to the US or Canada Polymaker stores. If you're outside, then there's a form with a list of filament that you can select from. Is there something unique about the Blackbox CE that solves a current 3D printing problem or issue? There are not a lot of true tool changers out there. So I say that would be the biggest one. That's me. There you are. Congrats. And you even tagged me. Good job. You will get an email from me sometime between now and next stream, because that's been the trend. I got everybody taken care of from last week this morning, before this stream. And we are good. So congratulations. Congrats. You said you'll get an email from me. I still wait for your email? You got to get drawn first. Top chat. Oh, I'm in top chat as well. Let's go live chat. I keep forgetting to change that too. Okay, place those there. Bolt that in place there. Assemble this thing, which we did. Use the little spacer. You just avoid picking my name. Email doesn't run on Sundays. Hey, Armor 3D. Welcome. Okay, do this and that. Use the spacer. Put it in there. Tighten it down there. And now we get to this. So, XY axis idler corner brackets. I think I'll do again. I'll just get put my back put my back to the test. So we have an idler corner brackets. That is all of these. My parts list is getting shorter here. That's a good thing. Unpin the giveaway. Thank you. Unpin and edit the description. And save, and now all is right in the world again. All is right. Okay. Locate this part. So which one is this? This is one of those areas in the build where you really want to pay attention to which part is being referred to. I mistakenly put heat sets in this part when they should have gone in this part. And there is a height difference there, but I removed them. They came out fine. And it's just a through hole there. But you put the heat sets in the parts that aren't through hole. You can do it, put your back into it. Okay, so that part there is this one. And those are already tapped. So I did that. And then this part is this one. So that's the pair for those, which means this is the pair for those. I did that. I did those. I did those. I put those in. Does the Blackbox have other tool, or are they all print heads? Right now they're all print heads, but that doesn't mean that you couldn't play around with plotters or cutters or lasers or whatever. I wouldn't necessarily recommend lasers or cutters though. I'm not a fan of mixing additive and subtractive in the same device. It just makes a mess. And lasers have their own issues in making sure that you're properly shielding from stray pew-pews. Okay, and I did those. So we're gonna get 50 millimeter shafts. And we're going to need 4 of them, which is all 4 in this bag right here. So, and 4, it looks like they're all toothed. Okay, that's good, because I think we're out of the others. Thank you, YO Band. If anyone wants to get more, Steve Builds takes 35% off until the end of the stream. Was it 30 just a minute ago? 35% off now. Till the end of the stream, and you gotta be careful. This might be a long stream. Okay, so let's see how these fit. Let's see if there are any that we need to. Okay, so that one's tight on that side. Let's see. Those are tight. Okay. So let's just see if it's that. So that shaft there looks tight. That one goes on well. So we're gonna go there. That one's tight. That one's tight. It was 99% off. Okay, so all these are tight, and I feel like I need to probably sand all of them. Not necessary to sand both ends of the shaft. The pulley should slide onto the shaft with some resistance. It's probably going to go to about the halfway point, I'm guessing, on all of these. So, oh, maybe not. Oh, so 2 of them are going to go to the halfway point. Yep, I see where they go. And then 2 of them only go on to the end. So let's try both ends on these just to... Yeah, it did make a run for it. Yep, both of those are... It's a little better, but... Any stuff that'll strip the floor. So all of these need a little bit of help. Let's pull the drill out. And did I... Piece of sandpaper right here. rip that. Start over. I have a seamless shaft in my head. Okay. Make sure that's not warm. Okay. Not an if. Nope. Need more. Ron needs to design a CNC lathe for that kind of task. I have a lathe. One day I'll actually make it work. It's one of those 7x14 mini lathes. There we go. Oh. There we go. Off of Amazon that really needs some attention before it works well. Needs like a carriage stop or lock, that kind of thing. Okay, so that one I'm gonna leave right there. So then the other two, so those two go there. The other two just need to go on far enough on the end. I'm guessing you have a nice big lathe, right, Bill? Needs a little more. Then let it cool down. That's the Shearline lathes. Had mine for 40 years. Yeah. Size and cost are the limiting factor. Okay, that will work. So that one for there. One more. Now I know what the LL and LL Cool J stands for. Lathe love. Need more. Most rural machinists would call mine a small lathe, but just big enough for good quality work at a reasonable price. Yeah. I would love something along the lines of like what Blondie Hacks uses. I pretty much want that whole tool set. Seeing what she can do with what tools she has is inspiring. Let's go up. A little warm, so I gotta let it cool down. Where are we at? 118. And we're about halfway through this page. I don't know what that means in terms of time. And we should have a fully cured epoxy over there. What grit is the paper? I don't know. It doesn't, I didn't grab a piece that has it labeled. It's relatively fine grit. It's probably in the 200 or 3 or 400 range. Ugh. Making a mess. I'm gonna have to wash my hands. There we go. That will work. Now, let me go wash my hands real quick because it's, yeah, I don't want to get that all over these nice gray parts. Just throw this stuff away. I've got a sink right here. Okay. Okay. There. Okay, return to print belt corner bracket front bottom. Return to print XY axis belt corner bracket front bottom. That's this guy. Okay, it's got to be that one, right? Yes. And that gets one of the middle ones. These two are the middle, those are the sides. This goes through here, and I'm sure goes right up to that middle point. And this little guy goes back in here. I'm just going to set this on the table, and then I can press down onto there to make sure that's in a good spot. Okay. And then the other one of these, goes in here in the same way. Like that. And then the top goes on to here. You can see where I sanded it versus where I didn't. So I'm gonna set that there. Whoosh! Then, since that's stuck through there, set it on here and push. It took a lot of force because there's a lot of material here. That grub screw is not needed. Hey, Danny. Stop, I have a suggestion. I look at engineering drawings daily, and from that, avoid any confusion with wrong parts, including a small bomb on each page for pieces and screws. That is not a bad idea. Okay. Yeah, that is not. Okay. Put that in there. See if I can get the pliers around that. Oh, not quite. It's not all the way in. It's off by a little bit, but it's really tight in there. Even after running the reamer through, I don't think, maybe these will open up enough. Oh yeah, just barely. So that's gonna go in there. This is gonna go right there. That around the middle. There we go. Wayo Ben. It's always fun when we're on the same page. No hammer. It said no hammer. No hammer. These little bearings can't take it. See a clown hammer. What do we got? Cheaper parts. LDO uses better bed heater and has some nice extras as well. But you can always upgrade later. Because you do not have the tools with them. Yeah. Okay. Into the bracket assembly. Locate that. Do that. And then put in the 5 set screws. Only in those two? And 5 set screws everywhere. All the areas get the M5 set screws. A vise is just a tiny arbor press. That's something I don't have. I should get a little press. Little arbor press. Oh, are these the 6? I think I'm using the 6s here. M3 by 6. Where are the M3 by 5? Did I grab the 5s or the 6s? Those are 4s. M4 by 6. Is that what I did? No, that's M4. Where? Oh, here they are. These are by 5s. And okay, I'm using the right ones. Just wanted to make sure. Hey, Dr. Ronnie. Which one did I just do? That one. Yep, 5s. Okay, just making sure. Okay, and I think we go on to, with the hand vise still clamping the corner bracket assembly together, install 2 M3 by 25 to hold this together. I don't think it needs to be, I mean, what's, not sure why we need the vise holding them if we're just going to use a screw to hold it together. I mean, it's a nice tight seam there. I'm just gonna hold it and make sure that the printed parts are in alignment. There we go. Everything is together. Cool. Locate. So remove the hand vise and the printed installation tools. Locate one of those 2x6mm linear shafts. That's the itty bitty guys over here somewhere. 2x6. 3, 4, 3. Where were those 2x6s? 2x6. Thanks for having a real nice and fun stream. See you, Falkenstein. Falkenstein. Where were those 3x6s? Were they in the miscellaneous box? I saw, there they are. 2x6 dowel pin. So remove, locate into the location shown below until fully seated. That's right there. Okay. Tweezer time. That is an itty bitty thing. Okay, what is going to be my plan for this? What are those tiny shafts for? I think it's a locating pin for something else, but I'm not sure. Yeah, let's do this first. Let's use the, hold it this way, press it part way in, where it just holds there. There we go. That is that. I do not want to leave that cap off. We'll see what they're for. I'm not 100% sure. Okay, so then install 2 into the top front right extrusion. It goes on there. I want to skip that for a moment. Or maybe I don't. Maybe I'll just go with the instructions. Like, I'll just get more of a workout if I have to move the frame around. Whatever. See you, Hybrid. Have a good one. Thanks for being here. Okay, so all of those right there. Okay, so this is which side? Install into the top front right extrusion. So that's this guy right here. Front right in that location. It's not great for I guess it goes right there. Did that last time. Right there. And it's fun when you're halfway in a build. You see, yes. Demo, thanks for gifting memberships. Okay, so that goes right there. And then I think we have That looks like that. If I put that right there, it looks like the picture. And then 2 more on the inside. So over here. Oh, right there. Joffrey. Exercise expert, wouldn't that be resistance weight training? Okay. So something like that. And then locate this piece, which I have, and the insert's already in it. Place the front corner bracket on the inside corner of the front right extrusion and line up all the roll-in nuts with their corresponding through holes in the bracket. Oops, not there. Let's go here. So there, there, there. So which one? This is the one. So this is going to go in here like this. So about there and right there. Other side. There and right about there. Oh. Install M4 by 20 into those and fully tighten. M4 by 20. Gotta be these. Right? M4 by 20 socket head. That's 25. I think I've got them over here. Yep. So on the inside here, we're going to put these. Now before I do that, I want to see how this spacing actually is for the screws. Okay, that's good. Making sure I wasn't going to bottom out the screw on the extrusion. These corner joints are printed, but it's just a cover. There's a really well made machined aluminum corner bracket in there. They're actually pretty nice. I don't have any complaints on those. I'm gonna hold this in the corner pretty good. Then tighten this. Is this meant to be enclosed? It looks like there's no offset to the frame edge. It is meant to be enclosed. The enclosure hooks on these spots in the frame. So you'll see when it's all done. Okay, so that's those two. And then install a M4 by 25 to there. So that's M4 by 25, which is right there. Am I lined up there? Can't really see. This thing in here. There we go. fully tighten. Okay. Oh, and then note that the index hole location on the back of print XY backstop mount. What is that? Is that this thing? Oh, that's this thing. Oh. So this is, note the index hole location. You see that? That's that M2 dowel, that 2mm dowel. That's that 2mm dowel spot. This index hole fit into the pin of the corner bracket assembly. Install the printed part on the corner bracket assembly as shown. Okay. And then install a 40 or 30mm into the location shown and fully tighten. Okay. So this guy is going to go on here with that pinned in that location. Apparently that's really important. And a 30mm fastener to here. Okay. And this, yeah, that's an end stop mount location. Ah, here we go. As the next step says. Locate a black stop and orient it on the corner bracket assembly as shown. I'm still torn between over-engineering and nice attention to detail. What's your thoughts? So there's definitely a combination. I'll have better thoughts when it's done and I'm using it. But yeah, for sure. Electronics box has a black stop. Black stop right here. Black stop. Boom. And what size screw is going into that? It's going to go right there with a M3x8 socket head. Seems like an M3x8 socket head with a little washer might have been a good idea right here. M3x8. I'm going to look to see if a little washer is going to interfere potentially with any traces on this. Yeah, it could potentially. I would probably suggest, since we can't do it doesn't seem like a washer would be a good idea. I think a button head might be a slightly better idea here. That's going to go right there. Button head with just a little bigger head diameter. There's not a whole lot to this. I mean, it really just needs to line up with this magnet. I've got stops here to keep me from going all the way. But the Hall effect sensor here needs to line up with the magnet, and then you can adjust this magnet in and out as well. So this doesn't get any force on it. But if I had a choice there, I'd probably use a button head. Or a washer and a nylon washer or something. Okay, so now we're going to build the other one. So go ahead and continue my workout. Build the other one. There we go. Hey, David Lee. It's not a reed switch, it's a Hall effect. So it's magnetic, it's electronics. It's not a reed switch, it's a Hall effect sensor will read a magnetic field. Okay, so the middle one goes in here. that. And this one goes over here. Now, I'm actually going to, since this seems like it might be the easier way to go, push this into this side. Yeah. And it's definitely tight. So close. There we go. Got it, that little extra bit. Still not quite enough to reach into there. There we go. Now it's lined up. Oh, put a little bit of pressure on the plastic there. Okay, these go together. Those are in good spots, I think. Let's break out the vise again. Okay. Then this is going to end up with what size screws? Because I'm just going to put them in now. In 3x25s. I think that's what it was before, right? It's these guys. Nope, that's 20s. Must be these guys. Yep. Perfect time for a big hammer. No, hammer's bad. I agree with them on the instructions. Hammer's bad. I think this is a good time to hold this thing together before you put the grub screws in. Okay, grub screws. 4:44 a.m. Welcome, David. Good morning. What there is always a good answer to a problem, hammer. Tiny hammer does not work, grab a bigger hammer. Thwacker. I did the appropriate tappy tap taps when I was working on those extrusions on the Milo. Okay. Move the vise and print installation tools. We get to put this on basically the same way we did the other one. So we'll go to there. And we're almost about 70% through part 4 here. Is that what we're in? Guide 4? Yeah. No. Okay, we're going to be working on this side. That's pretty good. There, and 2 more. And go. And alignment. So this is going to go like that. Means goes right there. And goes, ooh, awfully close. And over here, we've got here and right there. Okay, M4 by 25s. Oh, hold on a second. Does that say, oh, that's M4 by 25s into the front. Did I miss 2 going into the side yet? No, we do the fronts first. M4 by 25s are too long for the, it's M4 by 20s for the other side. Pressing it up into the frame. So KCMO buff, were you offline? Just curious, when you got the gifted membership? That's cool, because that's the, as long as you're subscribed, you're eligible. But I'm just curious, the way that came through. Did you get a notification? Oh, see you, Timo. Have a good one. So what's special about this printer? It's a tool changer. It's a tool changer and it's beefy. No, I've been listening since the beginning. Ah, I see. Well, thank you. Oh, my stomach's growling. Okay, so that, and then install 2 M25s, install by 20s, I just did. And then, oh, we are at the carriage. I don't know what's going to be the best way to get a view on this. Might just be overhead. Because we get to grab our piece that we just epoxied, which it's been well over an hour. I've gotten gifted memberships while offline before. It sends an email saying you were gifted. Does it say by who? I'm just curious. That's what I was kind of getting at, seeing if we'd find out. Oh, yep. I forgot about the bearings on there. Let's get all those gathered up. It doesn't, it is going to be very heavy. Okay, so we got this guy. We've got those look pretty. Let's see. Epoxy there. Yeah, that just scrapes off with my finger. There's none on the surfaces where it needs to line up. Hey, Richard. So yeah, those are what we epoxied in earlier. It looks like they are good. So this is going to bolt to here, right like that, with some M3x6 flatheads. It's these guys. 1, 2, 3, 4. And I am going to do a little bit of Loctite on these. It says metal plate to metal, metal to metal. Even memberships gifted while present don't say by who. It only shows that in the chat for the stream. Ah, I see. That makes sense. You only know if you're here. Got it. I wonder where my other screwdriver is. Because I don't like using the ball end for this. It must be in the other garage. Yeah, whatever. Okay, so this is going to go through here. And bolt onto, where are you? There. Okay. Sounds like my wife's home from work. Hopefully my son did his chores. Okay. There. Playing with the E3D CAD for ages. Just haven't pulled the trigger yet. 2.4 with stealth tap changer is currently the easiest and cheapest technology to build. Why does it seem like the large printers have so many issues? I wouldn't think a larger print area would introduce many variables. There we are. Nice. Okay. This is not tightened up yet either. I haven't tightened these front bolts, so you saw all that wiggle. It's mostly in here, mostly at least in here. Okay, locate the NEMA 17 25mm. We're actually bolting a stepper to this already. Extruder stepper. Get more wires hanging out. Oh no, it disconnects. Nice. With the wiring connector facing up, and then secure with M3x6 flatheads. I'm gonna do the same thing. I'm gonna want to do Loctite on these. Okay. Boom. And boom. I wonder, are we gonna hit belts today? Not sure. Okay. There we go. Oh, locate print X bracket V2 part 1 and install. So I installed all these already. We're also developing a new for the IDEX. Rotate the printed parts and install 2 M3s. And then this is the one that almost got me. These are M2s, not M3s. So make sure you do M2s there. And then snap the X bracket part 2 onto print part 1 as shown below. Okay, so we have this. What is that part? That must be this. So we've got this part, and we've got a little part here. So there's a little shape there that matches. So snap it onto the part below. What if it doesn't want to snap? Okay, I'm gonna look at this a little closer, see what we got with this. This is my stuff. There we go. Let's first make sure that we're here is good. And then take my scraper, scrape this out a little bit. We're going to look at this piece. Do the same thing, hit the top surface here and in here. Is ease the edges up here. See if any of that little tiny bit of work helped. It did. So that's going to go on that. I think I am going to use my pliers to get that on there with less, make sure it goes on straight. Aha, that's kind of satisfying. Chunk. You try to push that on at an angle, since they're, the layer lines are not in your favor there, likely to break off that little indexing part. Okay. Is there a giveaway this stream? There was. There was. Did I give away? No, did I give away all of my? I think I gave away all of my. I didn't. Did I miss giving away Tuesday memberships? Tuesday, the 5 memberships. Because I have 5 left to give. Did I do that Sunday or Tuesday? Now that you're talking about that, it's making me remember. I think my general idea is I'm gonna save those for later in the streams. I gave it away on Sunday, or did I give it away on Tuesday? I did it Sunday? Okay. I'll do it tomorrow or Tuesday then for the other 5. I'll do it Tuesday. Okay, line up the X bracket assembly to the back of the X plate and loosely secure with an M3 by 35. Okay, so we're gonna work on the back of this. Maddie. Hey, take care, Maddie. Good luck with your printer. I wouldn't mind seeing updates as you progress on that. So, I give away Sunday. Okay. Bearded Bucket, thanks for gifted memberships. No. Crap. That was not good. Oh, good. It survived. It survived. I dropped the printed part because I forgot I had it on there. Oh, and that, this is where I was after, doing something like that, because this goes on here like this. And then there's a M5, M3 by 35 with threads, yes. Very knowledgeable. Awesome. M3 by 35. Is that these guys? Yep. M3 by 35 with threads. Oh yeah, that's better. It goes through there and loosely threads in right there. What? Oh, I'm sitting on top of the hex tray is why that was rocking. Install one end of the, oh, we got belt. We got belts. So, did it say get belts ready? I guess we just do it. Install one end of the 9mm belt through the back of the X plate with belt teeth. Well, we shifted around to the front now. We were just on the back, now we've shifted around to the front. And then locate one XY belt tightening tool and attach the tool to the end of the belt as shown. Then locate a CNC belt clamp left and secure. Note the belt clamp is oriented to keep the outside edge of the clamp flush to the outside of the X plate. Okay. So I'm just going to be moving this thing around quite a bit. PF Dennis, thanks for the gifted memberships. Okay, we need belts. Belts are in what box? Not in the motion box. These are the belts. So this says it's a certain length. That's a lot longer than is easy to measure. So I think I'm just going to hopefully route one of these and then cut the other one to length. Because this is a 1788mm belt. I don't think I can easily measure that. Well, maybe I can. Is this metric on here? Oh, that is. Flat tape measure. Let's see how this does. Let's do that. See if I can. I got one of those flat tape measures, and I'm gonna go to. Oh, it's actually gonna go off the end here. But that's okay, not by much. 1788. I mean, it's worth having fun with this, right? So there, and then here. How is this cut on the end? It's cut pretty good. Go. And we just go along this way. Since the time belt, you could count the teeth. I could. I thought about it actually. I thought about it. And I also thought, nah. So that's gonna go there. And I'm gonna actually cut this to a bit more than that, I think. Ah. Okay, so with both of those clamped there, 1788 is right there. Should I go, how much more should I go? A bigger bench to measure full length belt. Let's just go 1800. I think that's probably, there's gonna be enough belt here. And if I do it the same on both, then I'll know they're the same. And I can cut off the same amount. So let's go, that's the, there we go, 1800. 1800 teeth. I have a lot of 9mm belt. If I screw this up, I can redo it, but. Just do the same thing. This is mostly for fun. Just a different way to get this sorted out. Yeah, it looks like I have enough to, it looks like I have enough to do this. Maybe. Yeah, I'm not gonna cut this one yet. I'm gonna run this one and then I'm going to see how it goes. So let's do this. Text on the belt. This is the only text on this whole length of belt. Nope, both ends. Never mind, both ends. I didn't go long enough the first time. Okay, let's see. There maybe? What are we doing? We are on this side. We look at this, we're gonna come in from the back, and this is kind of a little bit of a pain to do. I feel like we might have been able to do this before we put this back piece on, but that wasn't too bad. Oops, that wasn't too bad. And then, oh, but I put it in backwards. Put it in backwards, so I got to go around this way. Is that correct? Need to go the other. There. Keeping the belts upright. And then there's a printed piece here that this goes in for some reason. There's a bit of schmuck in there. How did this print? Oh. Now put this in here. So then this comes across something like that for some reason. Do you always put belts with text facing up? Yes. It's 100% a good reason for it. That's gonna go there. So let's control this thing by running it through the idler here. Get back to catching the. There we go. Now I've got it kind of better controlled. So, and then I have a little belt piece here. So I think it's a shorter one. Here, it says to put this on there and then attach this with a M3x8 button head. M3x8 button head. These guys? Yes. Didn't have to think about answering that question. I had to think about how to answer it in the most, at least entertaining way as I could think of. One of my V0s when I noticed I had one upside down. There you go, Brian. How are you? That goes, how does that go? Do I have the wrong piece here? Oops. That's there. But this piece doesn't look like the belt piece I have. Is that correct? Maybe it's just revised. Toolhead design looks like it will have most of the weight only above the rail. Wondering how it performs. We will find out. Here, sorry about that. Let's try this. I think this is the piece, but it doesn't exactly look like the printed piece there. So I think this goes in here, and this is just making sure we have the right amount of belt stick out, I guess. Thought those were aluminum, the belt clamps. Locate CNC belt clamp. Thank you, Poity. Nope, you're right. Locate CNC belt clamps. I didn't read the CNC part. I saw those somewhere. I saw those. There they are. Same with one of the rails. Carriage text was upside down. No one would ever see it, but I know exactly. Having build withdrawals is not helping. I'm sorry. Okay, CNC. Nice little CNC belt clamps. That's neat. I didn't know if those were beta Wade stuff or optional. No, that's, I appreciate the warning. Okay, now we go through there. Bring this here. Looks like, it's kind of hard to tell. It actually looks like it needs to go the other way. If you're looking at the wide spot in the, we want the outside of the plate to be flush with the outside of the thing. So looks like this goes right here. Yeah, that makes it flush. Just started to print my ERCF E2. Awesome. Does that go into a spot on the bottom? Well, let's see what that is. 3. Guido, welcome. M3x45 into the locations shown below. That's not an M3x8. M3x45. M3x45. Is that these? Yep. Fasteners have been relatively easy to find. That's good. Way over there. Okay, where are you? There we go. Oh, and all the way through. All the way through. It actually just stuck out the other side. See? Okay, I think that's about right. Yeah, I'll pull on that until that's flush there. And tighten that. No Loctite on those screws. The intent will be the GPs. I don't know this assembly quite where it's going, so my hope was to put Loctite after I secured them both, but since this other one doesn't have anything to screw into yet, we'll see where it goes. I will have to pull it out and put Loctite on it. But yes, I would do Loctite on these. It is metal to metal. There's no like compliant thing in between. Loosely install an M3 nylon lock washer onto the M45 as shown. Okay, so that's answering this. And had this set up here loosely put in that screw and loosely secure that M3 by 8. Belt clamp is oriented, okay. Where's my little, I guess this will do. Little M. Loose. Okay, so still loose. Okay. Nylock. Pull the XY belt to bring the printed tool snug to the body of the X plate. Now what? Loosely install. Now pull the XY belt to bring the printed tool snug to the printed tool. Okay. Well, here, before I do that, let's actually tighten these screws. Since I haven't done that yet. I haven't tightened these. Let's put it to the back here so we can actually see. Here. And then I'm making sure these are even on either side. Have you called Grant yet to help with the belt routing? No. I'm sure we'll figure out something. So then the idea is this goes to the end here. Is what it says. Pull the XY belt to bring the print tool snug to the body of the X plate. Keep tension on the XY belt while checking the printed X bracket is aligned with the X plate. Okay. Fully tighten both button head screws going through the belt clamp. Okay. Hey, Ram. Welcome. Pull this one out. Put some Loctite on it. There's my little thing. A little Loctite on that now. Now that can be fully tightened. And the other one can be fully tightened. That's all. It's to check alignment. Okay. Oh, so that wasn't my wife before. That's my wife. Chat goes back 4 hours. Yeah, we're at 4.5 hours now. Okay, fully tighten both button heads. You may need to hold the lock nut captive. Also fully tighten the M3x35 socket head installed previously. Oh, that's the one that was over here. Let's make sure everything seems lined up. This guy can fully tighten. Okay. You still planning to water cool your VZBot? I have all the stuff to do it. I need my VZBot to actually work, and it has nothing to do with the design. It has to do with the display. I'm waiting for Mello to take care of the display on it. My display was wonky. That's the technical term. And once that's done, I'll actually be inclined to try to use it. So anyway. Fully tighten going through the belt clamp. You may need to hold, locate the remaining and insert through the back of the X plate as shown. Okay, so now they want us to go ahead and put the other side on. So let's go ahead and cut a, actually maybe here, I don't know. Cut another 1800 millimeter length. I wasn't going to do that yet because I have enough here to do 2 belts still, but this will be fine. Right there, and right there. Okay, this is all. This is the remaining belt. This is our one here. So we're going to do the same thing, it looks like. Where is the text on the belt? There it is. And this is going to go this way. Go here, yeah. Oh, that was a whole lot easier to get through than I thought it was going to be. Clear out the stuff from this little tool. This, oh, that's weird. Okay, we're gonna put that there. Then, oh, it goes upside down. That's why. So you only have to print one, well, 2 of the same thing instead of having to have a mirrored part. That's fine and makes sense. Okay, so that is on there. And then the same type thing, we're gonna put this around, but I'm gonna take this around the other idler to kind of help control it out of the way. There we go. And that goes like that. And we get our other metal. Does that go below? Oh, okay. And 3x8. Welcome back, Garrett. Quite like this belt tool. I do actually like this because it kind of holds, you're not losing it, it's not falling through. I do agree. Seemed a little odd looking at it at first, but there, and I put Loctite on it right away since now I know what I'm doing. I feel like we'll have it together in the proper way right away. So that's there. That's pulling from there. That's loosely installed. Hey, projects. The spindle won't spin ideal speed. The printer tool is inverted when installed on this side of the X plate. Imagine that. Locate the remaining and loosely attach to the plate with 2. Okay, so this one does get 2 in 3x8s. Okay. I think I'm just gonna tighten both of those because that's pretty much where it's gonna be. Okay. Pull the X belt to bring it tool snugly to the bottom of the X plate. Keep tension on the Y belt. Route the loose end of the belt through the rear axis bracket assembly. The smooth side of the belt goes around the smooth pulley and the Y bracket is shown. Okay. Now route the loose end of this XY belt through the rear XY motor assembly. The tooth face of the belt faces the tooth pulleys. Start by feeding the belt around the motor pulley and having the belt exit the motor assembly through the tensioner idler. The tooth belt should only come in contact with the tooth pulleys. Should not rubber touch any other part. Verify the belt is going through the tensioner housing and not around the Verify the belt is going through the tensioner housing and not around the tensioner housing. Got it. Similar to the AB steppers on the Voron, making sure you don't wrap it around that plastic part. Makes sense. So how am I going to get a view on this? How are we going to get a view of this? Let's go this way first. I think. Here, 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 maybe like that. But why is this tool shaped the way it is? I think for a little bit of flex, I'm guessing. Okay, so this belt here is gonna go through here. I don't have something correct. Don't have, is that correct? I think it's correct, but yeah, we'll see. We'll see where things line up. Okay. There's a little bit of an offset between this pulley and the stepper pulley. So I'm going to put a little pre-bend in that, make sure we're correct. And this is going to go this way and wrap around the stepper there. And I think this is going to be a whole lot easier to pull this. Even though we went through all that trouble of screwing it on before. I think this is going to be just easier to pull this off and then route it. So let's pull those out. This here, and just pull this through. That goes through there. This is going to go through. That goes like that. So this is going to go through right here and route through here. Because I don't imagine how I would have done that, gotten that through the back there in situ. Let me just put these back in and use our little printed spacer to set our initial spacing. There we go. Okay. Now what do we do? It's got to go around this back. Is that meant to be a tensioner? Looks like it only moves the belt a tiny bit. You only need to move belts a tiny bit when everything is assembled well. I'm just going to go right through here. This is our upper, so then this is going to go through right there. So that goes right like that. And then it's going to go around this guy and back to our carriage. And that, I think, is one belt path. How does that apply tension to the belt? So if this is, if you can see here, if I pull on this, if I pull here, it's changing the angle here of the belt. So it's basically pulling on this way when you pull this. Does that make sense? So anyway, that's around there. I think that's, let's see what the instructions tell us to do. So we did this, route the loose end through the rear by bracket around the lower pulley and through the slot. Did that. Tooth is to mate with the tooth pulley profile. And then we did that there. Is this the lower pulley, or did I accidentally grab the wrong? No, I'm in the correct spot. Yeah, I'm in the correct spot. Okay. So the left side of the x-axis is the front of the printer. Correct. And then route it back through around the tooth pulley and towards the X plate. And then we're going to route the loose end of the belt through the left slot in the printed X bracket as shown. And attach, okay, so we can take these tensioner pulley things off the front, so we can utilize them in the rear. Okay. Locate the print belt clamp right front and loosely secure. Okay, so I need to run both of these because I didn't leave my belts the perfect length that they say, this 1800 or whatever. So let's route this one. So once again, I'm going to just pull this thing off. Any reason why seems weird? On what? Any reason why what? Oh, so the left side of the x-axis. Oh, because I mean, you got a bank of tool changes, and this is how they decided to do it for an efficient. One of the things about this printer is it's pretty small footprint for having 5 tools and getting the 300 millimeter build area. It's really pretty efficient, footprint efficient. Nogarat, you out of here? I'm too hungry. I'm getting there. I'd like to get through. I mean, we're almost done with this part of the instructions. Would like to get through this part of the instructions. Hey, zombie. Yep. I'd like to get through part 4. This is part 4. Part 5 is super short. It's 2 printed parts. And then part 6 is starting to build the docks for the tools. This goes through here, across here. Put a little bend in it. There we go. And then through here. Hey, Liz, still around. Okay, so now work on the back side of this. Hopefully get a decent enough shot there. There we go. So this is going to go through here, and I think if I sneak up behind it, some tweezers, or if I do this, there we go. See how I did there? Put this in. Can't get a good view on that, but I got it. There. Okay. Make sure nothing's riding up on any flanges. So this is going to go here, and I've got obviously have too much belt. So this said to go how many millimeters of belt? This had said 1,788, and I did 1,800. So if I take this and put it on here, do we have about 12 millimeters or 6 teeth extra? I don't know if we have that much extra, but we do have a bit. Yeah, there's probably 12 millimeters there. It's if you pull it pretty tight. Yeah. Okay. So we need to cut 6 teeth off of this on each side to keep this the same. Oh, come on. So 6 teeth off each side. So 1, 2, 3, 4. I'm gonna go 5, just for the safe, and see what things look like and see if we can still tension it. So 1, 2, 3, 4, 5. So now this goes on here, pushes up into there, and then we go there. The other one, is that correct? Yeah, I guess so. Goes on there. Oh, Hendrik, are you the electroplating guru? Yeah, there's about 1 tooth of extra right there when I pull on it. I kind of want to let it stay closer and see if the adjustment in the belts is enough. Awesome. Did you? Oh, I have my stealth burner front in the other garage. I think I'm planning on putting that on 1/2 of my Tridex, on my IDEX printer. I just haven't gotten to it yet. Guru. Okay. Thanks for showing up. Thanks for watching. Okay, I went looking for the belt size. I need to scroll back down to where we were. This is the printed side. There we are. And this is the printed belt clamps. Why is... I turned voice-activated Siri off on my watch, and it was just asking for something. Now it's possible I might have pressed the button. I think that's... I don't know. That was irritating. Okay, let's go here. And these are M3 by 10s. M3 by 10s. M3 by 10. Where are you? M3 by 10 button head. Button head? M3 by 10 socket head. That's probably... Oh no, that's the ones that I pulled out into the things here. I'll make another one for the Hydex. You want a gold and silver plated front fascia. I have a copper plated. It's pretty darn cool. So it is for the top one is an M3 by 10. It looks like the bottom one's going to be one that goes all the way through. So that I'm going to go just to there. And then I'm going to pull this way. Oops, not what I wanted. Why is that bunching up? What am I bunching up on? Oh, I'm bunching up on the little stop. There we go. And go right there. Tighten this on. Oh, we're still at 35% off on the Hex Peppers hot sauce. End of the stream. Ooh, that's right, the GPs. And that would match the build pretty well, considering it's an orange printer with silver accents. A nickel one as the matching one would be pretty. And then the lower one is the M3 by 40. M3 by 40. That's one of these guys. That actually threads into the aluminum part in the front. Yep, I can feel it. So many orders from zombies. That's why I matched it for this. Okay, and then I think the other side is, so this is, you will now remove XX slat on the installed belt. This step is not to achieve final belt tension. Pull on the printed belt to remove slack from the belt. The XX gantry axis begins to move, then the tension is too tight. At the loose end of the XY belt through the smooth idler. Oh, is this just doing the other side? Yeah, I think this is just doing the other side. And then we're going to go here, and we did that. And now we have the printed part here, so that's a M3 by 40. Okay, so that is another M3 by 40. That's really all I needed to know. It's M3 by 40 with a printed part. Where'd the 40 go? There it is. Okay, so now basically we got this guy here now, and this right through there. So I'm basically going to hold that, just pull on that. This guy goes through there. I suggest you polish the copper and protect it with a clear coating. Copper and nickel combo would look awesome. It would. Absolutely would. There, that is tight. And then the other one is probably an M3 by 10. Yep. Unable to watch, stream, they advertise way too much. That's the thing that I really, and Twitch bugs me with their advertising strategy. What I really like about YouTube is I can say, I want advertisements for the VODs, but I don't want them live. And come around, especially as we were so close to each other. Yeah. Okay, so that is done. Oh, you will now remove excess slack in the installed belt. This step is not to achieve the final belt. Put the, oh yeah, align the screw. Yeah, it begins to move, then the tension. I think I'm curious what, here, let's find out. Let's see if we can get enough tension. Before we get too far, let's see if we can get enough tension in the from this. So let's just do it. I tighten this. Yeah, I don't think we can. And that is an interesting tension mechanism. Unless there's something I'm missing here, I'm not actually getting tension out of it. Am I missing something on how that works? Because I don't think that's any tighter than it was. Yeah. I don't see how that works. Now let's just loosen this all the way up. Huh. Yeah, if it tightens, it has to be on the ragged edge, and that's where I've got to pull my extra tooth of belt there, I guess. Let's keep this all consistent. Hey, Brent. So I was asking earlier, it looks like it's in line with the motor pulley. It's not quite. It's offset. So I thought the idea was it's offset enough that it, and you might just have like a millimeter of adjustment or a tooth of adjustment. Let's go ahead and pull one more tooth because I left one extra tooth on purpose. Oops, wrong. That's the one tooth right there. You can feel it, so I don't really need to even cut it yet. And this will be the same thing. There's the one tooth. You can see it move. Now if I tighten this up, actually, can I just pull? It doesn't tighten. How does this work? I mean, it does, but I mean, it tightens, but maybe I need that one more tooth. Maybe I didn't measure it well. Maybe I didn't measure it well. Let's try one more tooth. There's the one. Ah, there we go. I mean, it's basically now one more tooth. There we go. Is that even? Yep. That's the one tooth, and it's actually basically nearly tight enough right now. I mean, yes, it's tightening it, but it's doing like a millimeter of travel. And I mean, that's probably about where it needs to be, but weird. We'll see where it goes from there. But it does, I mean, it does adjust it, just not as much as I would have expected. I think I'd probably, well, we'll see. Do I have my, no, it's in the other garage. My little pulley tension meter thing. Anyway, let's see what's next. This thing. So only pull until fully tighten the 2 and 3 screws going through the printed rear belt clamp. Remove the printed tool. Locate the extruder drive modified set screw and slide this gear onto the shaft of the NEMA 17 motor. Where is that thing? Which box was that in? That's in the miscellaneous other? Yep. This guy. So this blast move, is there a way to belt up a trident like that? You can pull more belt through the tool head? Yeah. Doesn't have a whole lot of tensioning range because of the way it's designed. Correct. Breaks in and the belt stretch, you have to pull the tool head again. I'm not sure. We'll find out. We will find out. Slide this gear onto this guy. Ooh, that's a tight fit. Align the set screw hole of the gear with the flat of the motor shaft. Is there a flat in here that I'm supposed to line up with? Nothing modeled in. Custom printed. Oh, there's a taper to it. Oh, there's a taper in the end. Yeah. So that little set screw needs to line up with the that. And then, oh, there we go. And does it say how far to push that on? Slide this gear onto the shaft of the stepper. Okay. Secure the extruder drive gear to the shaft with a M3 4mm set screw. M3 4mm. M3 2mm. M3 4mm. I'm surprised it didn't have me tap those threads. Secure the extruder to the shaft with the as the screw tightens, wiggle the extruder gear to assure the flat end of the set screw mates flush with the flat. Okay, I'm gonna pull this off again then, because I think the best way to do this is going to make sure it goes on correctly and straight to begin with. So right there should be, yep. Okay. Keep the hub of the extruder gear slightly above the face of the motor to prevent the gear from rubbing. Okay, so just go in here and pull that off by just a hair. So that's all the way up against there. Some of this. There, I think that's off by just a hair. And then that M4 grub screw. I mean, not 4mm grub screw, not M4. Goes in. There, right like that, I guess. I don't know how much to tighten that. I don't want to put any force on it. I don't want it to strip. So I think that's okay. Okay. Now locate a flanged 5x10x4 and snap into the X plate as shown. 5x10x4 bearing. Flanged. That's one of these guys. 5x10x4. Okay. That snaps in. There we go. Right there. Locate print bearing flange pocket and snap into the back of the X bracket as shown. That's this guy. Gotta be, yep. That's this guy. And what do we do with that? Probably another bearing goes in there. And then locate another bearing to go in there. So this guy goes in there. Take a little just barely. See, it's in there a little better now. It'll probably fit in fine once it's actually held in, I think. Does a braking go into that part of your... Does a bearing? Yes, a bearing goes in. And I'm just, like the seam here, make sure the seam isn't interfering with that sitting in there well. And probably on the inside for the bearing. Okay, let's see how another one of these bearings goes in. So that guy will go. So I can press this in. Maybe the Nipix. Hey Derek, welcome. Welcome back. Okay. The nice thing about these is it gets everything parallel if you're careful before clamping in place. Of course, you got to be not at the end of travel. There we go. Interesting solution. The bearing would go into the back of the printed toolhead part. Well, I think we could probably tweak this to not need this little extra piece. That goes in there. It doesn't snap in, but I imagine there's a piece that probably holds it in. Kind of scraping this last little outer layer off. I don't know what holds that in. I guess we'll find out here in a moment. So that goes on there. And then locate the CNC tool change lock and slide through the 2 flange bearings starting from the one on the X plate. Then locate a T-lock shim. I know what that is. Okay. So we've got this guy, which is this. And, oh, there's a couple of things in there, additional things, a E-clip and probably a shim. Oh, 2 clips. Okay, so let me set these aside. Circlip, yep. So this is going to go in from the front, but it says locate in 2 flange bearings starting from the one in the X plate. Okay, so it goes through the front. Locate a T-lock shim. Slide 1 shim off on the end. Okay, so we're going to go there, and then this side goes in here. Now, I don't know what stops this from. Oh, there's a. It doesn't tell us to put that circlip on there, does it? Push the shim past the groove. Okay, so where were those itty bitty shims? That's that. They were in the miscellaneous box. Not that one. Those. 5x6x40. Looks like these guys probably. Locate a T-lock shim. Now this says 5x6x40 shim. Is that a T-lock shim? Be certain to push the shim past the groove. Okay, well, let's grab one of these. Wow, these are really small. So how long are you letting the beard grow, or are you just going until Milo says long enough? I'm growing until April says long enough. I don't know how much longer that is. That might not be too much longer. Okay, so that goes past the groove. It's got to go past the groove. Okay, so there's a little groove right there. Make sure that gets past it. There we are. Now locate the 4mm E-clip and snap it into the groove end of the T-lock. Slide 3 more T-lock shims onto the end and slide them all the way to the E-clip. So is that this one or that one? this one? This one. Guessing it said this one, so. There are actual tools for this. Oh, it's on there. I see. And then I think the thin one goes in the front. So now it says 3 more of these little itty bitty shims. See ya, Jarrett. Need the proper tool. Yep, that worked fine. 1. Okay. Oh, 2, 3. Some were still stuck on the end there. So 3 more. These things are really, really fine. Oh yeah, if I had the snap ring style, I have snap ring pliers. Okay, so that's gonna go on there. Not really thrilled with how that printed part is fitting, but whatever. Is the printer a bit rectangular to give tool heads more room? Is the printer a bit... Oh yeah, yeah. No, it gives room for the tool heads. Okay, locate the print T-lock shim pocket and slide it over the end of the T-lock and press it flush to the back of the X bracket. That must be this thing. These small, I'm not a fan of these tiny printed parts. This goes on here and breaks. It immediately broke. Not a fan of, I'm gonna have to reprint that now. Because these tiny printed parts are not great. Okay, that's gonna need to be reprinted. And then locate a backstop and place it on the X bracket as shown. Why are we doing this now? Why don't we finish this little assembly that doesn't hold here in place? This thing that doesn't hold here in place until you put a circlip on the front. Should have reamed that part out before putting it on here. But I'm gonna just do that for now. There's something we're gonna put on the back here. It's going to have that little gear, so this might be okay, having that part broken. Electronics, another black stop. And what are we doing here? With 2 M3x6 socket heads. Okay. 2 M3x6 socket heads. M3x6. It's these short ones. So here. Camera angle doesn't help me here. Is this a free? Oh yeah, sorry. See, this guy. This guy is right there. But let's get this guy in here. was not great view, but that is what we were installing. Come on. And then this is still in need of some, there, that's where that's gonna go. And there's, I think that little brass worm gear is gonna go right here with the NEMA 8. We get to install the NEMA 8 today. XY belt tensioning. Stepper motors will produce electrical current when turned by hand. The clearance between this tool and the belts is, if you are unable to or unwilling to disconnect the motors from the, be certain to move components slowly. Move the X carriage. Okay. Locate tension tool and place on the machine and location below using similar procedure. What? Yes. Flush to there. The goal is to tighten the tension of each to prevent skip steps during operation. Excessive tight belts are not better. And then you tighten those two. Turn each equal amounts to keep the tensioner block and pulley parallel to each other. I don't get the reason for those printed guides. Okay, I'm skipping all that. Oh, completed that. We've completed guide 4. Best group of people. Yep. Very, very happy you were able to make it, Bill. Very, very. Well, that is guide 4. I'm a little puzzled. I want to look at guide 5 here because there's no mention of actually finishing this shaft piece. And I'm guessing that's in guide 5. Let's open it up. Standard tool lock. Okay, so this is guide 5. Zoom in so we can actually read it. You can have Bill Brothers do a guest host stream. That would not be a bad idea. Was that where you wanted to be? Long build, perfect for me. We can probably get through guide 5. Guide 5 we can probably get through today, and then I'll be really happy. We got some parts, preparations, best to lay out all, standard tool lock. Locate a M3 by 35 and fully secure it to the location shown below. Okay. So the shaft assembly is the lock to lock the tool heads on. I'll give you a little better view here in a minute, but I think finishing this will make the setup a little more like secure for the next to wait until next Sunday. Things aren't really fully assembled right now in the tool head here, and I think if we can get past this part, it'll be a lot closer. M3 by 35 flathead. It must be this guy. That will probably make more sense when I get. Yeah. So that guy goes right here. So that just threads into a tapped hole in the aluminum plate. And then locate the lock motor install tool. That is probably in this other group of parts that I brought over. Where did I set those? There they are. I thought it would be. Oh, there. That's got to be it. No, that's not it. That's not it. What is it? Standard lock motor installation tool. 1.7. So this is basically saying to space it out 1.7 millimeters. I don't remember seeing that. This is guide 5. So if we go back to STLs and guide 5, there's a tool. Did I not print that? Huh, interesting. I didn't print it, but it's 1.7 millimeters. We can deal with that. The shaft in the extruder, yeah. Snap the printed installation tool onto the NEMA 8. You get to play with the NEMA 8. Itty bitty. Shown below. Locate the worm gear. It was in miscellaneous. That's this guy. So this is a brass worm gear. Slide it onto the motor shaft and until it is flush. This thing is so 1.7 millimeters is what we'll be looking at there. So I will get that figured out. And then what grub screw is this? A M3 2 millimeter. Just because there's not any more opportunity for this comparison. Ugh. There we go. Need black stop stuff also. Okay. That is funny. Okay, 2 millimeter grub screw. That is a NEMA 23 for something. Definitely for something. Okay. A bit of Loctite. NEMA 23 is for something. That's what I said. There we go. And that goes right there. And then, what are we going to say? How close am I here? 1 point, it's not quite, it's not 1.7, it's like 1.5 right now. That's close to 1.7. See if I can get in there with my calipers. Not really. It's 1.7. It's perfect. It's really close to perfect. It's as close as a printed part would have gotten me. Looks about like that. No, Wade's probe. So you're saying you want to build an even smaller printer with NEMA 8s? Yes. Yes. Something. Exactly. Something. Okay. As this screw tightens, wiggle the worm to ensure the flat end. Yes, it's there. Tightens that screw. Remove the printed installation tool. Locate print tool lock mount. Print tool lock mount standard. That is this guy. Oh, and that's going to go over that part. So it sandwiches this thing. So that really doesn't matter. Hey, Kyle. How are you? Just get the flats. Everything looks pretty okay here. Okay. I need a heat set, an M3 heat set into there. Is that the only heat set on here? Okay. Where is my 4mm reamer? Maybe I'll put it back over here. No? Boy, where did I put my... Kick that away. Where did I put the four? Oh, there it is. So I've found on these parts, it's working a little better for me to where I have to put a heat set. I just ream it out a little bit just to give it a little extra room. There we go. And then heat set. There we go. 1, 3. Hey, Truex. That printed gear on the tool head mount, is that an extruder gear? Yes. Yes. That's to interface with the extruders on each tool head. So the way this printer is set up, each tool head has its own extruder setup, but it shares the extruder stepper on the tool head. On the carriage. Shouldn't that part be metal? What part? Oh, apparently not. It seems to work fine. Okay. So that, and then we're going to place the NEMA 8 inside with the wires in that orientation. So that goes in there. And then we're going to hold that together. Center the motor in the cradle. Pay attention to the wiring harness connector orientation. Secure the motor with M2x8 socket heads with 3 of them. And then place it onto the X bracket and secure with M3x25s there. So what am I going to do? Try. Come on, give me right here. Not the frame. Not the frame. There. Okay, I need those M2 by 8. M2 by 8. Where are those? M2. Where are the M2 hardwares? Three by 8. Are they in the box? M2 by 8. Oh, these are all tool head kits. That's not going to be in there. Tool head hardware kits are different from the others. What are the M2 by 8? Is that what these are? No, M3. These are 40/40 extrusions. If a plastic gear message with metal gears and extrusion, would that lead to premature wear? It's meshing with plastic gears. The plastic gear is meshing with plastic gears. You'll see. You shall see. Where are those M2 by 8s? Are they in here? They are. M2 by 8. Those are not socket head, but I don't see M2. Oh, those are M2 by 6s. I see. Here's the M2 by 8. With it being a tapered spline gear, I would think that as long as it's not spinning, the alignment is close, should be fine. Okay, so this guy is what we're going to start with. Put this on. The extruder portion is printed by IGUS in their special material. It's like a slick Delrin. It is special. I don't know if this has some play in it, or some adjustment in it. I think that's for meshing to that worm gear. So I'm not going to tighten this very tight yet. As if you see here, see those are slots. So I'm just going to get that in there. And then M3 by 25 socket head. That must be these. 2 of these. The fastener kit has been really good for not having to worry about finding stuff. Anything I haven't been able to find, I haven't, it's been right where it should be. Okay, so that goes there, I guess. Okay. Install and fully tighten M3 by 40 into the location shown. 3 by 40. Okay. That turns fine. And then install and fully tighten in M3 by 8 to there. Okay. And then locate the worm wheel 1 to 40 5mm bore and place it on the T-lock shaft as shown. Okay, so I have this. Push the worm wheel flush to the printed standard lock mount and orient the grub screw hole to face the flat end of the T-lock shaft. Check the worm wheel is centered to the worm and then coat a M4 by 5mm set screw. Start by securing the set screw facing the flat. That screw tightens, tighten the M3 by 5 set screw completely. So that's going to go in there like that. Let's go here. So I say there, and then that should go into here, apparently. There we go. Does that go all the way? Okay. Pushes against there. And that does that. Okay. M4 by 6. M4 by 4. M3 by 5. M5. M3. M4 by 6. I'm finding M4 by 6s. Didn't this say M4 by 5? M3 by 8. M3 by 5. M4 by 6. M4 by 4. It said M4 by 5. What's that one? Not that. Not that. M4 by 4 or M4 by 6? Which one do we use? Because I don't see an M4 by 5. I'm going to go with the M4 by 4. I'm going to go with the M4 by 4. Until I find where I tucked away the M4 by 5. Okay. Okay, good. Bring this. Let's just, I guess, turn it. I gotta get an angle on it. Okay, then turn this where it matches, right there. This guy goes up in here. Okay, I think right like that. Okay. Push the worm wheel flush to the printed standard lock and orient the grub screw hole to face the flat of the end of the T-shaft. Check the worm wheel is centered to the worm. It is centered to the worm. And then coat a M4 by 5 set screw. Tighten. So this little typo here, talking about an M4 by 5 and then we got an M3. So just a little typo. Locate the print tool lock index. I got that. That is right here. This little piece. Print tool lock index and secure a 3mm cylinder magnet into the location shown with CA adhesive. The magnet should be flush to the back side of the printed part. Note that the back side of the part has a raised feature for centering. Okay, this is another one of those cases where the contrast on this is not good. Steve Bill, sorry to go off topic, but on your polyester, how long did it take to dry out a spool? Polyester? I don't have any polyester. Had mine on for 48 hours and continued on high, it's still at 21%. Wow. Want to try to build a cycloid drive? Seeing your worm gear makes me think about doing a 50-to-1 cycloidal. That would be fun, playing around with those. So this is a 3mm thing. It goes in here. That is why it needs to be flush on that side, is because it goes up against a thing. So it says Blackstop is polarity sensitive. So how do I know which side to put this in? How do I know which side? Final position of the lock will be set later. And then a black stop will go right above it. If this is important, then how do I tell? If this is important, then how do I tell? Let's go here. So this is going to go on here, see? And there's going to be a screw that goes in here that then we can lock the timing in place. Hey, John. Oh, the Polymaker dryer. Most of my stuff has been within a day of getting it down into the 10% range. Tested on the Blackstop magnets already installed. Okay, that's a good idea. Good job, Poity. I like that. That should be that 3mm magnet. Where are all those magnets? We've got a 3x3, is that what it is? It doesn't actually say. It's just secure a cylinder magnet, a 3mm cylinder magnet. So what if we go in here and undo our isolating stuff? Go in here. I wonder if I can get a view on that. There it is. It is 1.18 by 1.18 millimeters. That's not right. Let's find that in the browser. That's not 1.18 by 1.18 millimeters. Isolate. I for info, outside. It is 3.175, which means it looks like it's a 3x3. I don't know why it's this size in CAD here. Yeah, it's 3x3. Okay. Is that water cooled? It is. It is. Okay, so I have a 3x3 here, and I think Poity's idea is genius. So if I take this to, let's say, the side here, and there. So that is going to be the orientation. I've got it stuck to the XY joint thing here. Where did I put this? And this is going to go on here. Maybe this is a better view. This is going to go on here. So this is basically in the opposite. Is it the opposite or the same? Excuse me. I need to put it the opposite orientation. because it's reading from the back side. It's reading the opposite side. So this has to go on. Let's see if I can just, you know what? I need a 3mm reamer. I'm gonna ream this out to 3mm and then we'll glue it in place. There's my 3mm reamer, might be over there. I'll ream this out to 3mm and then we'll glue it in place. Where is that? Okay, and drill this out to drill this out to 3mm and then we'll glue it. I don't know where my reamer is right now. As sorry, my voice. As I was looking for, as I started drilling, I found the reamer. So, oh, there we are. Excuse me. So, do that. And then this is going to go like this. Sorry about that. There's something in my throat that's not happy. So I think I want to just reverse this here. So that, yeah, I think it goes right like that. We are still at 200 people. That's awesome. And then I think a little bit of thin CA on the back and some activator, hoping. So I'm going to try pushing this under flush, put a little bit of thin CA, and then push it to flush, and then activator. Let's see if that does a quick little, let's glue it in place. Yeah, sorry, I was trying to figure out, because magnets, Hall effect sensors, it's the orientation of the magnet is important. There we go. So I pulled it through. Now I'm going to put a little bit of CA glue, and this is thinner stuff. Just the tiniest little bit. Don't need a lot. Then I'm gonna use this bottle because it's HDPE or whatever. It should be resistant to the plastic, and I'm gonna push that in. Oh, sorry, you didn't see any of that. I pushed the magnet into there. Where's my paper towel? There it is. And then a little bit of activator. There. It's a Cyclops smiley face. Good night, the GPs. Okay. So, and with light pressure, it doesn't push through. So I think I glued it. So then that goes in there. That's way too funny. Gear. What size screw went into that? An M2 5mm. M2 5mm. I saw an itty bitty. This was M2 6mm. Thought I saw another itty bitty screw in here somewhere. M2 5. It's not M2. It's not M2 6. I'm gonna try this one. Ooh, almost dropped it. Let's see if this will tighten down without bottoming out. Do not put Loctite on the M2. No, wasn't going to. There we go. Okay, so that is that. That's that. I don't know if there is an M25 somewhere. I'm probably going to find all these fasteners I'm missing. I can't find. Place a black stop. So let me grab a black stop. This is the last black stop. How is you adjust the lock location? That is how you adjust the lock location. Super smart. Yep. And then fasten a black stop to it with an M3x6 socket head and install in the remaining 2 fasteners M3x6 socket heads down there. Okay, oops. There. So M3x6 into 3 of them. This guy is going to go right here. And that magnet is going to pass by the sensor here. So that'll rotate around and pass by this part of the sensor. Then under these guys right here. Okay. We got something. I think that's it. Okay. That is as far as we are going to get today. Let me zoom out so we can see our progress. All the things. Place the bed back on here. There we go. Okay, it is belted up. We have a gantry. And the next bit is going to be the tool docks, which is exciting. I was prepared to do up to 2 of those today. All the parts are quantity 5. But yeah. These things can come off of here, and we'll play around with those belt tensions. I think the idea is these things have all of about 1 millimeter of belt adjustment. Oh, come on. Oh, that's because I was trying to pull it the wrong way. Awesome. So Tuesday we are back on the test station and Recore A7 build. How far we get on that will depend on how much I can make progress on redoing the power supply wiring. But I am doing a full 5 tool build. Yep, I figure if I'm going to do it, I'm going to go all out in the initial build, because if I don't, then I'm not likely to add tools later. So doing the full 5 tool build. The tools end up right here. The tools end up here. Here's the front of the printer. Tool head moves around, and tools are along here with the water cooling block and all that stuff. It is chunky. It is heavy. But yay, I'm glad to be at a point where it's belted. So something that I want to do is observe the belt alignment and see if I feel like I need to make any adjustment in the pulleys, and I can get to the grub screw right through this. That's the end of the stream. You'll have 10 minutes left to get 35% off at Pex Peppers with Steve Builds as a coupon. Good. Thanks, Garrett. So yeah, I'm gonna move it around, kind of see what how the belt path settles in. And for those that wanted to see a little better, I don't know what that was, I'll find it later. This was that lock. So the NEMA 8. So the NEMA 8 moves this guy. You can kind of see it moving. Yeah. Anyway. Progress. We are on to part 6. Part 6 next week. So with that, thank you everybody. Thanks for the new members, gifted memberships. Thanks to Polymaker for the filament giveaway and KB3D for enabling this build. Thanks for everybody hanging out. We've got a bit of a 6-hour stream here. So that's about where I feel like these are gonna be. So I'm not building this into August. So have a good rest of your Mother's Day, good rest of your weekend. Hopefully we'll see you on Tuesday. So take care, everyone. Enjoy the build. Bye.